Amdad.
I think. So welcome back to the technical sessions of one-day workshop on recent advances in ocean science and technology. I request Dr. Tata Sudhakar, Head Ocean Electronics Group NIOT, to introduce the speakers of this session and take over.
Thank you. Good afternoon, everyone. We have three speakers in this session. Dr. Kawakoshi from Japan, and Professor Merello from France, and Mr. Zakaria, of course, in France, but in the first speaker is going to be Dr. Kawakoshi. He's a principal research scientist and director planning and coordination.
Excuse me, Dr. Tata, sir. Your volume is very low. You're not audible. Can you please increase it, sir?
Is it okay?
Yeah, a little louder, maybe a little closer to the mic here.
How to do that?
Everyone, can you see my slide?
Yeah. We can see.
Okay.
Give me 1 minute. I'll finish up my introduction. It's okay, Nidhi?
Yeah, I'm fine.
Yes, sir.
Hello, Dr. Atmanan.
Yeah. So I will speak loudly. I don't know how to increase the volume, so I'll speak loudly. He's born 1964 and received his BE in Ocean Engineering and MS degree in Marine Sciences and PhD degree in Marine Sciences from Tokyo University, Japan, and visiting professor in Sokai University and visiting professor at Institute of Industrial Sciences, University of Tokyo. He is chapter chair of ITC OES Japan chapter from 2015. His background of work is underwater robotics and ocean observation system development, especially submarine cable observation. He is going to talk on initiative for unmanned marine observation and related technology in cancer. Over to you, Professor.
Thank you very much for the introduction. Can you hear my voice again?
Yeah, it's very clear. You can go ahead.
Okay, thank you very much. My name is Takeyoshi Kawaguchi, JAMTech. First, I'd like to celebrate Dr. Atmanan on your retirement. Now, we really appreciate your hard work and the dedication. And in addition, congratulations on the award of the National Award of Excellence Ocean Technology of the Ministry of the Science Government of India. We Japanese research community are very happy to hear of your success. So the title of my presentation today is the Initiative of the Marine Observation and Related Technology. But I want to start my presentation from the topic. Okay. So actually, I'm not sure when we first met with the Atmanan, but I remember the conference in Tokyo 2013 very well. We also engineering community in Japan held a conference called the Underwater Technology UT that year in Tokyo. This is an international conference organized by the IEEE and OES Japan chapter and has been held every other year since 1998. We have participated in the UT13 hopes of attracting the next UT15 to NIOT, I remember. So this is a group photo at the time. It has to see that close up here in the middle, the of that line there, and the above and there. So at that time, that the activity very well and successfully how to coordinate the next underwater technology conference UT15 will be held in India. And this picture is also UT13 Professor Ura, and over the bottom of the UT4. to the floating market. And after that, in October 2013, the pre-event of the UTW13 was held at NIOT. And 2 years after, in 2015, UT15 was held successfully at NIOT with a lot of the people. Okay? So at the same time, a joint research plan was being discussed between the NIOT and JAMSA, and also the NIO in India and JAMSA. And September 2014, MOIS and JAMSA signed and concluded the letter of intent to start new research cooperating activities in the field of marine science and technology. And after that, November 2016, a memorandum of understanding based on the LOI was exchanged to completion with the Prime Minister Modi's representative. So this is a picture. Ambassador Chinoy and Dr. Tyler, the former Jampa CEO, stand in front of the two prime ministers. So as our research and development exchange has had a very good influence of the diplomacy of the two countries. So based on the friendship of the Dr. Adnan has accumulated, we wish to deepen the communication of engineering development between the countries and the countries. I hope. So this is a brief introduction of the life. And so let's go down to the business. Initiative and then knowing of the basin and the related technology. Okay. So the ocean has the potential to the various resources such as energy, food, and the minerals. The efficient use of these resources will play a role in the future. So many countries are looking for the way to explore and acquire these unknown resources. So when you go to the place you do not know, so what is the information you need to master in energy on the map? So now we have extremely detailed map information in land. When you go to the Google Earth and Google Map, you can easily grab the map information with the map for basic information at the time. So when you face up to the moon, when you face up to the sky at midnight, you can see a very beautiful moon there. The moon is located 3.8 million kilometers far from the Earth. The surface of the moon
If
is
you go
mapped
through
at
the
a
literature,
resolution
there are
of,
various.
do you know how much resolution? Can you imagine it? It's 10 meters. And when you face down, there is our mother Earth. So the same question, the surface of the Earth is mapped at the resolution of at least how much measure? It's 1,000. This is an image of comparison of map resolution between the moon and the Earth at this map. Where does this difference come from? Because the shadow can't be measured on the sky because it's covered by the light. So at this moment, 50% of the picture is measured by acoustic apparatus. And but the other 85% is just calculated by using the gravity anomaly. Most of the ocean floor is measured by only the 10,000 or 1,000 resolution. So this means we do not know many parts of the earth. So if you need map information with the same accuracy as the moon surface, you need to conduct surveys approaching the seafloor using a kind of robot like this. Using AV is the most effective way to get the details of network map of the seafloor, but it has some problems with the presenter-person method. To use the AUV, you need a support software for maintenance and the position data acquisition. We must run and recover AUV every time it needs maintenance. This means usually every day. And process data analysis is performed on ground usually separately from data acquisition. So this means analysis results are obtained only after the tools is complete. And the most clear thing is data users and engineer on board must fight this to run this. So this is a video clip of everyone's operation. You can see there are many difficulties in continuing to carry out this kind of operation. It's very fast operation. So we're proposing a new way to operate AUV. It's an SV means autonomous process system of the AUV management. When users or scientists order the data acquisition, the service provider, that means engineer, prepare AUV S3 equipment and conduct an operation on the nearest third-party server. S3 handle the multiple AUVs at the same time, and we do not need to arrange the shift time of packet data or get on board. If the acquired data can be transmitted in real time, it is possible to realize the data immediately. We aim to establish technology that can provide this service and cover one quick process. In the end of the 2016, Royal Dutch Shell sponsored Ocean Discover X Prize with a man. X Prize is a non-profit organization in the United States that design and manage the public projects. And Ocean Discover X Prize is an ultra-wide range, high-resolution, info mapping competition using unmanned tools. So we list to share this news and to challenge the X Prize, young researchers, engineers from Japanese national institution, university, and countries come together, and the team, one team was formed. It's named Team Rocio. Rocio means a black current. It's a very strong current flowing to the side of the Mars. And this slide shows the timeline of the competition. Ocean Discover X5 is a competition takes more than 3 years, very long competition. There are two stages before the final, and that is proposal review and the other is appeal prize. 32 teams are posted the proposal and 11 teams dropped in the proposal review. And on the 10th team that at the team trial. And the final stage was contested by 9 teams. This tells that the finalist the team pressure is only one team advancing from Asian countries. And the final competition itself was held in Kalamata, Greece in December 2018. So this is a short movie of Team Croatia final competition. So what the video was short for, hopefully for. How it works. So the announcement of the results of the final competition was held in the Monaco Oceanographic Museum in May 2019. The team Croatia fortunately did the second prize in the final competition, and we were able to demonstrate some of our technological goals in the competition. And the research said that this kind of reveal that it will be the football future research. So the end of my presentation, I'd like to show you some of the features of unmanned navigation. This is an image drawing And the left part of the figure is X-drive concept-based ASD of the ASD solid system. So NIOT installation. It is easy to handle that not fit for the survey of the distance. It is range roughly 50 to 100 kilometers from Chile. And to solve this problem, we start to discuss the possibility of unmanned flying boats of the observation system development to covering the EV of 200 nautical miles from shoreline. So we Japanese research community hopes to achieve certain results in this development approach within this new research. So we believe the realizing of the variety of unmanned exploration technology accelerates the efficiency of the very end of my presentation, I love that to the document. Hope you enjoy your retirement. May this retirement be your happiness. Thank you very much.
Thank you, Dr. Tawfiq. Next presentation from Professor Guerrero, Life Fellow of ICT, Director, CISP. Professor Guerrero, Professor at IMT, Campus of Fellow ICT, head of the program at ICT. He worked in many institutions.
Thank you.
Yeah, thank you. He worked in many institutions like Nova, Telecom, France, and his main research interest is remote sensing and 3D signals and statistical and spatial analysis applied to remote sensing detection of character signals. For the last 2 decades, he has worked in the development of signals and image for the intersection of radar signals, either natural, like wind, waves, and current, or man-made, like shifts and positions. These applications were supported by several European projects and investment contracts. Professor Guerrero has authored and co-authored 40 papers, 130 conference communications, and 3 books. He has supervised more than 30 PhD students. For all his work, Professor Guerrero initiated the grade of fellow ICT class in 2006 for the contribution to the signal processing applied to the remote sensing. He has many awards. Some of them are the out for you. He is general chair in the ICT OES, which actually has created 2 oceans per year concept. Previously it used to be 1 ocean, and then from 2005, I think it is 2 oceans per year concept. And then Gallo is elected president of ICT OES for 2 years and re-elected in 4 years. You can start.
First, I have to put my mic on. Thank you. I'm going to share my screen first. I would like to congratulate Dr. Admanan. Not congratulate because he's retiring, but congratulate him for all the work he has done. He has done in at NIOT and in the scientific community. Dr. Admanan is also an OES, Oceanic Engineering Society administrative committee member, and will be our United Nations Decade for Ocean Science, which is very important. So is going as Dr. Kawaguchi said, is going to enjoy his retirement, but still is going to stay involved a lot in the scientific world. So I'm going to share my screen. Let's see. Okay. first, it's beauty is everywhere. Okay, so but that's my screen. Now the presentation. Okay, here it is. Do you see the presentation, everyone? Yes.
Yes, we can see.
Okay, so I'm going to that's a nice follow-up from what the presentation from Dr. Kawaguchi. As he explained, the Jamstack and NIOT were and are still connected into the let's say below the surface underwater technology world, AUVs and etc., which was the subject of the UT 15 in Chennai, where an event I attended, and at this time I was president of the Oceanic Engineering Society, and that was a very, very well attended and well organized event, and we're looking forward for if the situation improves for the oceans in Chennai, hopefully in time. So I'm going now to talk about things that are above the surface, but with a lot of processes which are at the level of underwater. So it's monitoring marine pollution, and really doing that from space in my applications. But I'm going to present two different parts which are related to man, that is humanity, and unfortunately, and that's the pollutions from ships on the ocean and marine litter, which is coming from everywhere, and marine litter, especially plastics, which are also a very large pollution source. So, ocean oil pollution. In in the end of the 90s and the beginning of this century, we had several very large accidents of ship releasing tons and tons of oil, and then that is very mediatic in a sense that makes the news. But when you look at the amount of oil which is released, it's a one shot, a one event, but every year, and this is a picture of the Mediterranean, and it's a study which I participated to during a European project called Marseilles, and this project showed that every year there is the equivalent of 100 time pollution made by a ship sinking, and this is only in the world. And in the Mediterranean, you see the traces of all the pollution that can be detected from space at the surface. Of course, for doing that, we need a good coverage. And fortunately, with the orbiting satellites around the Earth at 800 kilometers. For instance, in the beginning of the century, at 2001, the coverage was already thousands of images available. Nowadays, of course, 20 years later, we have tens of thousands of images and data available. So really we can follow and we can track the pollution. I did a zoom. Hello? I did a zoom. Okay, I did a zoom on the part which is the south of France. You see the island of Corsica and Sardinia, which is from Italian country, and you see a plot of the all the spills that are over a short period of time depicted and obtained through the satellites. Of course, they come from somewhere. They come from ships. So you have also a lot of ships. In 2004, for instance, using only 80 images, or 79 in this case, and we made a detection of all the ships that were circulating over a small period of time, and we discriminated between the reliable targets. Is a duplication of on the screen, and the unreliable one, and you see that there are a lot of ships. So if we detect a pollution, where is it coming from? The idea is to detect the ship, detect the pollution, and get a match. So it's quite easy doing the detection. It's quite easy when I'm going to show you with my pointer. Okay, the detection here of the oil spill behind the boat. The boat is detected as a radar image. The boat is detected as a white spot here. It's quite easy in the Mediterranean when there is no wind, so the surface is quite flat. You see the roughness of the surface, and then you can say, oh, easy, okay, I detected this one, the pollution is here, so this is this guy here who is responsible. And as it is in international, it's not in international water, it's in French zone, French water, then you can send the army, navy, and says the ship. Of course, this is a very easy situation, and it's not very often that we get that. So when the situation is more complicated, like this one, for instance, it's at the, this is Brittany. Well, I know it because I live there, as well as Manel Zakaria, the next speaker. So we detect, or the company we are working with, which is called CLS, we are detecting a pollution. So this is an enlargement. You see the pollution here. You see many boats already there, and that's not enough. So we have to connect with the another database, which is the automatic identification system that normally all the ships have on board, and there you can see all the ships that are sending this information to the database with their position, GPS position, with their route, where they are going, the speed as well of the ship, and on this map we also plotted the wind speed going from southwest to northeast, the southwest to northeast, so this direction. So that's already 3 sources of information, and that's a paper that was published by CLS on that at the bottom. And combining all these sources of pollution plus a model of what we call it a drift model, that is, because of the wind, there is a drift of the boats, and there is a drift as well of the oil pollution. Then we can, in a sense, go back in time and say, okay, if we take into account the wind, the direction of and the speed of the boat, and where it was at the time of the pollution, we can focus and eliminate hypothesis of among all the ships, which one are possibly the polluter and the one that are not at all possibly the polluter. So we have a map like that, where you see all the ships, you see the routes. The ships are going either south or they are going north. Because of the pollution and the shape of the pollution, we can eliminate all the one going north. Then you have several going from north east to southwest, and the same direction as the wind, by the way. And the pollution is here, and we have 3 different, or in this case 4 different possibilities. So these 2 ones are going to be eliminated, and I show you on the next slide, because we look and we apply the drift, and they are, with the drift, they are not close to the pollution. They are not close to the oil pollution, so they are eliminated, and the only remaining one is this one, and it fits. Okay, and as it was not very far away from. Pardon?
You can hear me also? I mean, probably.
Yes, but sorry, I'm talking.
See you.
Hello, Manel. So, yes. So this is the only candidate, and then all this information that you see on the right hand side of the slides here are passed to the French authorities, what we call in France the préfecture maritime. That's prefect of the region and maritime region, and then this authority, they can order the Navy to go and seize the boat because there is enough evidence that this boat, this ship was the polluter. Okay. Going to marine litter, it's of course a different story. In marine litter, you can see the marine litter and plastic and the fishing nets and whatever is floating on the ocean because it was either downloaded in a sense from commercial ships, or it was coming from big rivers which are sending this everything in the ocean, or coming from the everyday life and everything going to the ocean. So I gathered 3 different maps, one from the European Union, which shows all the places, the beaches where you find litter, mainly plastic, but not only plastic. The next one is from a colleague she's working at NOAA, and of course are more interested in the United States coast and also the Pacific. So you see all the places where they gather and they have marine debris or marine litter monitoring, and I don't show the amount of pollution here, the amount of plastic, but it's tons and tons and tons. And the last one is a global one where you see, it's very interesting paper from the Clean Sea Well, and and you see where the main pollution could be. For instance, due also to mismanagement of waste, like City of New York is a big one. You see a lot here in the Caribbean because it's the Mississippi River goes into the Gulf of Mexico, and all the plastics and pollution and litter goes there. Yansekang in China. I mean, you have places, many places around the world with that. So, what can we do? So far, we have the possibility of dozens of observation satellites in space. This is just an European Space Agency picture. That plenty of satellites. The European Union and European Space Agency have a collection of satellites called Sentinel, and each of them is dedicated to 1 or 2 sensors, like radar sensors, optical sensors, multispectral sensors, and detecting at the surface of only the surface of the ocean information as different as the sea surface temperature, the sea surface height, the roughness, the waves, etc. So, is it possible to see from that directly the pollution, the litter and the marine plastics, the marine debris? The answer is no. It's too small. I mean, it's the same kind of comment that Dr. Kawaguchi gave, the resolution that we have for our own surface of the Earth in a best of case with radar is 10 meters, or optical is 10 meters, but then it's on a small patch. The global one, as he mentioned, is around 1 kilometer, and it's good information anyway, but not enough for plastic. So we should go to other kind of information where we know that the plastic and the litter is connected to. So this one, okay, that doesn't want to go. So just 1 second. Okay. So in between the satellite orbiting at 800 kilometers and drones, which are nowadays a promising device and promising sensor, but of course a drone doesn't fly very high. Drones or airplane, they don't fly very high, and they are observing a very smaller patch, but still it's possible to have a very good resolution with that and detect plastics when the plastics are macro, that is a larger size. In between those two, we have companies nowadays starting to send in space what is called nanosatellite or CubeSat. It's about a 10 by 10 by 10 cube, 10 centimeter, I mean, and or globally 1,000 cube centimeters, which is a liter of water. And they put small devices in it, small sensors, but they send a lot. The latest one I saw, they send constellation, not of 2 or 3 or 10, but a constellation of 3,000, 10,000 of this. So they are orbiting very, very rapidly at about 200 kilometers, and their aim of getting some other kind of information. They are not observing, but they are getting information from buoys, from whatever is on the surface. And that is the next step, and what I see as a future. It's having satellites and other devices like that linked to what I call transmitters, that's objects at the sea surface, transmitting information about not only the state of the surface, but also because they make some measurement or they are related or connected to AUVs or gliders or other underwater devices, we can have the coupling between that with the model of the ocean circulation made by the oceanographers, and with the something coming from the telecom industry, which is the information and directly transmitted to the satellites, either the orbiting satellites or the nanosat. And also the information which is on another database from the people cleaning the beach, from the either directed by the state or from NGOs. So the future for me, it's the development that I would call the Internet of Ocean Things. Actually, we know the Internet of Things. We know that there is a big part of the industry which develop what they call connected object, like your fridge or like your car or like everything that is used in everyday life, and their objects are connected and they belong to that very large Internet of Things. That might be useful or not, I don't know. But for concerning the ocean, if we have a lot of this kind of devices, small buoys, whatever, on the surface, then we can map and have a better information. Of course, having all this information and these different databases, especially everything coming from space, it's not humanly possible to look at that and make a decision. We can make a decision, but processing is very difficult. Now it's in terms of bytes, it's 10 to the power of 20 every day. So it's a petabyte, I think, the name of data coming down and with different formats. So the future for me is having the observation, but having help from the artificial intelligence. I put a slide here which present that what is called here the real world, that all this information is going through a chain. Okay, it's looked and measured by sensors. It's processed or pre-processed. Okay, you have this different reduction of dimensionality because there are too many data, and then you can make prediction. Okay, and you have a model. The model is what it is. It's wrong, but it's useful. And in the end, you have an analysis result, and then the human can make a decision. The processing beneath that is a bit a buzzword nowadays, but it's called either machine learning or deep learning. In the past, in the 90s, we call it neural network, but okay. And but nowadays it's very powerful because we have the machine behind that. So another slide that I borrowed from a colleague of mine in Italy shows that the word that are interesting is intelligent, smarter, adaptive, evolvable. The neural network is processing beneath. The computing should be evolutionary. Everything that the machine can do, that's the artificial intelligence, okay? And in the end, we human, we decide. So I translated that into the drivers for artificial intelligence, 3 plus 1. We have data and we have more and more data. And when you talk to scientists or practitioners, they said, yes, of course, but we need more data, we need more information, we need a better resolution. Dr. Kawagashi showed us that the surface of the moon is a 10-meter resolution, the surface of the Earth is a kilometer. So what if we go down to a 10 meter on the Earth? Well, there is a factor of 100, so more data. We need models, and we need, of course, computational power. I visited IBM in the United States when it was still possible to go there, and they are working a lot on the quantum computing, which is increasing by a factor of a long, 100,000, the possibility of calculation. Of course, that has no sense if we don't add something which is us, that is you in this case. Our brain is going to interpret the final results. So finally, I would like, because I've worked for this study with different organizations, of course, the IEEE Oceanic Engineering, my institute,
they
but
can be designed in such
the
a way
Blue
that
Planet,
they are safe against
the WWF, and NOAA. And at the bottom, you see also that everything is under the control, if I could say so, of the UN Environmental or Environment Program and the Sustainable Development Goals. And I usually put this one as the last one if you have questions, but I don't know if we have time for questions. Thank you. Okay, I have to go back and
Yeah.
Okay, and I stop sharing my screen.
I'll introduce the third speaker for
Okay.
this session, Dr. Manish Zakaria, received engineering degree in physics and electronics from and master's from University of Mexico.
Tata, your voice is a bit feeble. You please keep very close and speak. No, it is not really audible.
It is that, sir. I changed my mic. Is that? It's not here.
Slightly better. Yes.
Sorry for this. The next speaker is going to be Manish Zakaria. Professor Zakaria received engineering degree in physics and electronics from NIOT and master's in acoustics from University of Sydney, 1979, and PhD in acoustics from University at Excellence, June 1980. He was actually almost coming almost 80 years. He is presently in the French embassy in India. He has been chair and co-chair of many international conferences. He received EIA award from the European University Institute, London. And then honorary fellow from ESL Acoustics of India Institute, and fellow member of IOA Institute of Acoustics in 2010. And he has participated in 11 scientific uses for proof of concept and experiments. He has supervised 7 PhD theses and 35 master degrees and 70 master projects. He has totally 362 publications and reports. It's over to you, sir. You can start it. Sir, Zakaria.
Good morning, everybody. Do you hear me properly? Good. Want to share some thought of you. First, I really want to thank you for this invitation, which I accepted with pleasure. And my talk will be about synthetic aperture imaging and how it can be helpful for seabed mining. I know how the NIOT is interested in that. Before starting my talk, I would just like to say that this is a very old Indo-French friendship story. My first contact with the NIOT was in 2013, more than 7 years ago, in Indo-French Conference on Acoustic that we co-organized between the French and the Indian Acoustical Society. And then when I was in India, I had a long visit to NIOT where I had seminar on underwater acoustic with the team working on underwater acoustics. And then I was sent by the embassy together to a meeting together with Ephraim and Naval Group trying to set up a letter of intention. Then I came back the same year to Underwater Technology Conference, which was a successful conference organized by NIOT. And 3 years later, I came back again with a delegation, French delegation, during the what we call the Jeanne d'Arc mission, the mission of the French cadet of the French Navy. And they had a stopover in Chennai, and then we again visited an IoT together and discovered every time new things. And then I had the honor to be invited to the Silver Jubilee of an IoT together with people from Ephraim. And then finally, it came the other way around. Dr. Dilshara Japan was visiting us in Brest together with a group of Indian scientists to prepare the Knowledge Summit, the second Knowledge Summit. And recently we also had a visitor from the French ambassador of Ocean who visited you, as I know. So due to all this summit and the action, now the priority of both French president and Indian prime minister is on the ocean and ocean monitoring and blue economy. But we were well ahead of the politician with establishing those links. And those links was possible thanks to Dr. Atmanan, because he had a very open approach to scientific cooperation and very open-minded and try to push the things ahead. And that makes things in cooperation much more easy because scientists then can really cooperate with support from the top. And I want to thank him for inviting me several times to an IoT and for supporting his team to open themselves and go and cooperate with the foreign country, in particular with France. Sorry. Something is wrong. Oh, sorry. So there is a growing interest, as you all know, in NIOT, in deep sea exploration. And one of the major issue is to have specific survey tool that could image the zone and predict the concentration of nodules, for instance. Of course, exploring by a manned submarine, as you are planning, is an issue, but it's, you need to know where to send the submarine. So you really need to survey a large area of interest. And this is really an essential point, as you all know. But there is a really specificity in nodal field survey that the object of interest are very small and they are spread on a very large area. So from sonar point of view, because the objects are small, you are looking for high frequency. But because you need a large area and a large coverage rate, you need also low frequency. So we need to have tools that will break this dependence between resolution and frequency. And this is where synthetic aperture sonar will come. For people who don't know what synthetic aperture sonar, I will say a few words, and then we'll show you some example. Synthetic aperture sonar is a technique that was introduced in radar a long time ago, but in sonar in the 90s. And the idea is to implicitly include the ship movement in imaging sonar, and in this way provide a azimuthal resolution that is frequency independent and an axial resolution which is all as usual 1 divided by the bandwidth. So the idea is to move complexity from vehicle design, from big ship design, and to processing aspect. And due to the increasing in computer processing capability, this was possible with less than 10 cubic meters. So the idea is very simple. If you have a sonar moving in this direction, the same target, because you don't have enough resolution, will be seen on, will be sending many echo and will be seen on different pings. And this, what we call trajectory of the echo, can be computed in advance if you know your velocity and your geometry. And if you can compute it, you can inverse the computation and put all these wavelets in phase, add them together, and then display the data. So it looks very simple here because you just see that it's more or less a geometrical building of the images. In conventional sonar, every ping will be displayed. Here we display the result of summing up all these pings. So performance, in short, the angular resolution is inversely proportional to the length of the synthetic array. This, by the way, could go up to 100 meters in virtual and handling with a 1 meter physical array. And of course, you understand that handling an array of 1 meter is much easier than 100 meters. But the interesting thing also that you can adapt this length to the situation. So if for close by target, you will have a shorter synthetic array, and for long target, you will have a longer array. This is what we call dynamic focusing. And at the end, your resolution does not depend on the range, does not depend on the frequency. It's half of the physical array. So if you have an array of 1 meter, it's 50 centimeters. But because we integrated the trajectory in the beam forming, that means you are subject to any trajectory disturbance. And this is where the big difficulty is at sea. As you all know, nothing moves as you were expecting. So a lot of effort has been put in correction and focusing algorithm. So I'll show you some result because I think illustration is more interesting than going into equations or anything like this. So this is one of the first prototype, which was a low frequency one, which was shallow tow, about a few hundred meters, that we worked on. That dates now in this 90, which was financed by the European Commission. And that was a proof of concept. In the 90s, nobody believed in synthetic aperture. Everybody was saying that this is like kind of mirage and it will never work. So the first thing we have to do is the proof of concept at sea. And to do that, we had to put our own target, find them in a very complex environment. So the target we had in the experiment was corner reflector. They were fixed on a wood frame just to show that they are sitting near each other. They were something like 400 meters in the water, yes. And that was the first time we could prove the concept that if you do the processing, instead of having very big, I would say, sequence of echo of the target, you can focus them on a very small point. Of course, this has no, I say, practical use, but we had to prove the concept. And the most difficult part, we spent hours looking for those three targets among everything that was sitting on the bottom. I like this picture because it really illustrates the capacity of synthetic aperture in maintaining the range resolution, the angular resolution constant. Here it's a very rocky area in Cavalier area, which is something like a few hundred meters deep. No, 200, sir. And it is, you can see that the small rocks is a fully rocky area. I mean, you could compare it to, if you scale it to nodule field. And you can see that the very close target are well identified as points. But when you go far from the sonar, those points are spreading on several meters, and you end up with a mess between them. But if you do the synthetic aperture, you realize that your resolution here, 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 and at the long range is the same, and you can clearly identify the rock separately, one by one. And it illustrates the capacity of such a technique to improve the resolution and the image quality. Image quality is not only resolution. We realize that it's a combination of, I mean, when you talk with the expert, it's a combination of resolution, of contrast, of signal to noise, etc. Many different parameters are indeed interfering together. Most of the people focus on resolution for image quality, but it's not the only argument. Of course, this had very quickly naval application. This is sonar images obtained from Navy sonar and a courtesy of Thales company, where people now are not looking at small objects, but are bigger one, like a cylindrical mine, spherical mine, manta mine, which is a pyramidal mine. And they, in fact, do not image the object. They are imaging the scattering from the bottom, and the changing of scattering in the bottom is the indicator of the presence of an object. This is a shadow approach. And from the shadow, you can say the type of from geometrical consideration, you can say the type of object you're looking for. Synthetic aperture has a big development in the end of the 90s in Navy sonars. And now most of the companies are providing synthetic aperture for all the Navy around the world. So it become now a routine technique in naval application. I will focus more on civilian ones, and the following images will be a courtesy of XBlue and of the area of interest, which is the deep sea. This is a 6,000 meter sonar at 50 kilohertz. And just to show you again the improvement in image quality, I mean, it's in resolution, but then you see it everywhere on the contrast between this area and this area compared to this contrast here. And this is now a commercial project, so we have something like, I think, 3 or 4 commercial projects, not too many, because civilian sonar business is rather a small one. So we have maybe 5 or 6 now products and few prototypes, again 5 or 6 running in the world. So just to show you that now you can apply it to deep sea. And when you apply it to deep sea, when you have a deep tow body, people are complaining that deep tow body are moving too slowly, but for synthetic aperture, this is an advantage. So you transform your limitation to another advantage, because if you are moving slowly, you have many pings from the same target, and you can increase the resolution by using this ping for synthetic aperture. This is another sonar images again from deep sea, but with a wider swath. So you have 1 kilometer swath on each side, which becomes now interesting from the coverage rates point of view. And as you see the density, as you will see, the density of information is very high. And if we zoom on this area, we will get these images where we have a zoom on the feature, and I'm going to zoom on this small feature again, and then we can really see the reverberation. And here we have a resolution of 2 meters by 15 centimeters. So more and more application are trying to set up this high resolution system. But then we end up with a big problem. I mean, if you have you just ask for 10 by 10 centimeter resolution, you will end up with a huge amount of data, which is several gigabytes for a square kilometer. And if you are exploring an area like this, you cannot print it. You cannot have an operator watching at those different scales. So you see something at this scale, and this is something very different at this scale. So the increasing in resolution is a very positive from understanding the physics, identifying the object, but it brings so much data that it cannot be processed and interpreted mainly in real time. So you really need now, and this is where the things are going, computer tools to reduce this amount of data for every users to something that a human operator can operate. So this is where now all the big data algorithm and artificial intelligence is coming in image interpretation, mainly, for instance, for navies. I don't like the artificial intelligence way. In the 60s, when we started this algorithm, because this is when the artificial intelligence started, they used to say it's an auxiliary machine for the brain. So this should be really viewed not as replacing operator, but helping the operator in digesting this big amount of data and helping him in classifying the important object. For navies, it will be mine. For oceanography, it could be the changes in the bottom structure. For exploration, it could be presence of nodules of oil, of volcanoes, etc. And the reduction of amount is really tremendous. For instance, if you survey an area of 1 square kilometer of mining campaign, you have nothing. This is what you are expected. You reduce your data from several gigabytes to 1 word, nothing. And the amount of data reduction is really impressive. And this is where the physics modeling will come to not fool the operator by a misinterpretation of things. And this is again another example where you can do mosaics of several synthetic aperture and explore very big areas. So now all the conventional tools that used to apply to standard sonar are applied now to synthetic aperture, with the big constraint I mentioned, that when you increase your resolution by a factor of 10 by 10, you increase the amount of data by a factor of 100. India has already, I think, bought one of these sonars and using it on the Indian coast, as far as I know. I think this is all I had to say, and again to thank you for inviting me and giving me the pleasure to discuss some issues with you. And I have a special wishes to you, Atman, that you will, I know how much busy you were, and then you have a kind of big rupture in your activity, and hope you will find good activity. And even if you are retired, I've seen that the retired, past retired former director, many former directors are present in future events in India. Hopefully one will be able to travel to your country, and we really wish to be there. We will also see you, and we'll meet you around in an NIOT or in other conferences. Thank you.
Thank you. Excellent presentation. This concludes actually this session. We had 3 presentations. Dr. Kavakuchi has titled Initiative for Unmanned Marine Observation, and Professor Guerrero on monitoring of marine pollution from space, and Professor Zakaria for synthetic aperture sonar. Thank you all of you for my presentation. Yeah, in my part, I think I need to say thanks to Dr. Arman. We worked for last 25 years here. And then I think once he has introduced me to the management of the event, we started with YouTube 15. And of course, almost all the 3 speakers are actually participants of that event. And then, of course, we did a very good work in IISF because of that. I wish him all the best. Of course, he's going to be an active person, so he will be around, I know. So I wish him all the best for him. Thank you very much. Nidhi, my partner. Thank you.
Thank you, Dr. Tata, for effective handling of the session. Moving on to the next technical session, I request Dr. B.K. Jena, Scientist G, NIOT, to introduce the speakers of this session.
Yeah, good afternoon to all. Thank you, Nidhi, and thank you, the organizers, for giving me opportunity to introduce great eminence scientist of the globe. And my both one is Professor Goku Kundu, who is very
We are
well
not able
known
to hear you.
NIOT. So
We are able
We can hear.
to hear. Yeah.
is now okay, clear?
Yes.
Okay. So sorry for the disturbance. And just I have two speakers. One is Professor Gopu Pute, who is known to NIOT, very well known to NIOT, all of us. And second is Dr. Hanuman Singh. So first of all, I request Mr. Professor Gopu Pute to give his talk, but I am going to introduce a brief introduction about him. Professor Gopu Pute is the BSc Civil Engineering in 1985 from the University of Kerala. Then he moved to Ocean Engineering in IIT Madras. Then after that, he has done his PhD from University of Rhode Island. And after that, he became a faculty at the Department of Naval Architecture and Ship Technology of Cochin University. And now he is the fellow. He has worked in various organizations, and some of the few I'm just going to tell here is a fellow Acoustical Society of America, and he has served as a co-chair of Acoustical Society of America. Also in various other society like IEEE, Ocean Engineering, and other things. And he has contributed more than 25 years on naval research. And he is a member of various oceanography society, as well as he is maintaining a close research collaboration with NIOT Chennai and participated in the two Indo-US workshops on saltwater acoustics at NIO Goa in 2010 and at NIOT Chennai in 2011. He has developed and offered a 5-day course on fundamentals of ocean acoustics to the scientists in India at National Institute of Ocean Technology, Chennai, in the year of 2011. Now I welcome him to deliver his lecture for this workshop to the honor of Dr. M. Athanam. Welcome, sir.
Hello, good morning here and good afternoon there. Can everybody hear me?
Yes, sir.
Okay. Thanks, Dr. Jaina, for the nice introduction. As he mentioned, I'm no stranger to NIOT, so it's nice to see many familiar faces in the screen. First of all, I will like to thank the organizers for inviting me, and also wish Dr. Atmanand a peaceful retired life if that's what he wants. Let me try to share now the screen. Okay. Can everybody see that? Okay.
Yes, sir. You can make the full screen.
I'm going to do that. Yep. All right. So this talk is not detailing any specifics. Mostly like a very top level, top down talk, talking about the challenges and complexities that we acoustical oceanographers and underwater acousticians encounter when we do observational acoustical oceanography. So many of the things that I present is applicable to any ocean related activities. So I start by making a statement here. Solving important problems in ocean that are exceedingly complex and frequently impossible to solve with perfect accuracy may require one's willingness to cross disciplines. I highlight that cross disciplines there, and understand and appreciate the complexities which we all know that ocean is a complex environment. Complexities of a naturally occurring medium and possess the ability to combine intuition with mathematical skills. So it's the medium is complex. You have expertise. You need expertise from many disciplines, and when you combine these two, things are little difficult to achieve. So the aim of the talk is to highlight some of the complexities and challenges with some of the examples from my past experiments, and hopefully some positives at the in between. Again quote from Medwin, Clay, and Stanton from an ASA, Acoustical Society of America article here. They state that the basic challenge to the vast complexity of the ocean, both in description of the ocean and of an acoustical signal traveling through it. So I mentioned I am an acoustician, so I'm interested in the propagation of the acoustic energy through the ocean, and when the medium is complex, that creates problems. And to solve that problem, the boundary conditions and the medium, the properties of the medium must be known. So both are complex, both are complicated.
I am happy towards that.
And on top of that, further complicating the problem is the fact that most of the properties varies over time. So there is a time dependence due to the dynamic nature of the ocean. And sometimes, depending upon your frequency, certain aspect of the seafloor, which generally can be considered static, under certain conditions, like when the sediment is transported by ocean currents, you add more complexity. So to take care of these complexities, or to overcome these complexities, you need a lot of resources if you want to solve the problems that you are trying to solve to a degree of accuracy that you require. An example is shown on the right. That's from an experiment that we conducted on the east coast of United States in shallow waters, shallow meaning roughly around 100 meters, which was called Shallow Water 2006 experiment. So in order to monitor an area of around 10 kilometers by 10 kilometers, during that experiment, we deployed 7 ships, 62 moorings. Some of them are acoustic, some of them are oceanographic. Aircraft overflights, satellite coverage, a fleet of 10 oceanographic gliders, in addition to help from data assimilating numerical modeling and real-time data communication from a number of shipboard experiments, all with the help of dozens of principal investigators from many institutions, including Woodsell Oceanographic Institution, University of Delaware, and other institutions in the US and abroad. So the reason I am mentioning is that data is costly. You need enormous resources to pull something of this nature. And when you have when you are competing for resources and money or funding, it sometimes becomes difficult to convince the program managers and the policy makers an effort of this kind unless you are really good in communicating the payoff, the advantage, or the usefulness of the result that you get out of this. I mentioned multidisciplinary nature of the result. That is becoming more and more obvious nowadays. Earlier, we used to compartmentalize our research into people with similar backgrounds. Now we are trying to open up and bring in more and more disciplines into tackling a problem. So in other words, we are trying to become more problem centric rather than program centric. So another challenge involves the fact that in order to solve any given problem, it is likely that in addition to acoustics, I'm focusing on acoustics here, but it's applicable to any other fields in ocean related science. There may be up to several areas of oceanography involved, and specifically for acousticians, we need to work with physical oceanographers, marine biologists, and marine geology. Now, the problem when you have a group of people with multidisciplinary expertise, sometimes communicating ideas, because every discipline has their own way of communicating things, their own way of identifying problems, and it requires little effort to understand the viewpoint of others and assimilate that into design of experiments. An experiment which we conducted recently in 2017, again on the east coast of United States, was the called the seabed characterization experiment. It was conducted in a place called New England Mud Patch. The uniqueness of that experiment was that the experiment was conducted in an area where the top layer of the sediment was mud. And mud and acoustics have a very interesting relationship. The sound speed in the mud is typically lower than the sound speed in the water column, and that creates unique propagation conditions. And that was the scientific objective behind that experiment. So since we are dealing with a new material, usually the rest of the area in United States East Coast is sand or silt, which we are very, very much familiar with. This was a new type of sediment. We needed a lot of help from geological oceanographers and geologists. So we had to bring in a lot of geologists, and they became very useful contributors to the overall achieving the overall scientific objective of the project. So the emphasis on interdisciplinary nature and contributions from various disciplines cannot be overstated. So when you go big, usually the observational programs nowadays integrate a lot of institutions, a lot of groups within the institution, a lot of institutions in the country, and some of the big programs are international. A lot of countries also involved. So when you have such a diverse group of participants, management skills to navigate personal, institutional, and interactions between countries, and sometimes conflict between these personal and countries becomes it requires great management skills. And that's probably one of the skill set that people, the scientists, usually scientists focus on science and doesn't bother about other aspects of project management. But sometimes it may be nice to have to develop some skill sets in managing people and managing these kinds of issues. I still remember the big experiment, which was called Asian International Acoustic Experiment, or ASIA-X, which we did in 2000, which involved countries like USA, China, Korea, Taiwan, and most likely Singapore also. I remember John Potter involved in that in experiment. So that was a unique experiment in the sense that we, the scientists who participated in that experiment, learned a lot from each other. There were ships from multiple countries, scientists from multiple countries and different ships. But to pull that off, I can still remember the effort, the countless number of phone calls and meetings which the PIs, the principal investigators, had to undertake to get through the various maze of regulations and rules and issues that came up before the experiment. But when it was done, it was a huge success, and it's a unique experiment. Another area which is of probably of interest to many will be the distinction between basic and applied research. Is that the support for basic research is restricted to or mainly come from government funds, taxpayer money. The private sector, because of the profit motive, they always look for low risk, high payoff research. But I put that book, which I came across recently. This was a theory put forward by the founding dean of the Harvard School of Engineering and Applied Sciences, V. Narayanamurthy, and he says this traditional model of separating basic and basic or pure research from applied research is flawed because it assumes a linear relationship between the two that need not always exist. So he argues that the discovery goes both ways. Both the basic research learn from the applied research or use applied research tools, and the applied research often learns or the fruits of the basic research trickle down to the applied world. So inventions draw on scientific knowledge from the basic research, and scientists often gain insight from new devices and applications. So he concludes that it is highly non-linear because they must feed on each other. So nowadays, even though most of my and our group's research is on basic research, there is now a push to make sure that the outcomes or the fruits or the results of the basic research is transmitted or transitioned into the applied research community, so that in a sense the program managers themselves are answerable to their superiors, and in order to justify the allocation of resources to basic research, sometimes it is necessary for them to highlight these applications that the basic research eventually produces. So an example, right now we are in the middle of a big $15 million observational program funded by BOEM to monitor environmental impact of offshore wind farms. That is purely an applied research program because we just go there and collect data. That's what we are tasked to do. But we were able to convince the sponsors to put some additional sensors so that we can squeeze out some basic research into this particular program. So an example is shown there. So Y.T. Lin, a good friend of ours from Uppsala Oceanographic Institution, wanted to consider the propagation of the three-dimensional propagation aspects of pile driving noise, which is purely in the basic research, cutting edge research area. And we were able to put some sensors to verify his modeling. And eventually, our hope is that these types of advanced modeling will translate into some kind of, in this particular case, some kind of a regulatory metric for the regulators to implement in their regulatory process. One of the good things that's happening in almost all fields of all aspects of our life is the role of advancements in technology, the new technology, new toys, cool toys that are coming and helping the discovery and scientific discovery aspects. In our case, the autonomous underwater vehicles, AUVs, gliders. You can. This is a glider, and this is an AUV. And autonomous surface vehicles, drones for aerial surveys. All these are giving us more flexibility, more tools to undertake our discovery, and sometimes cut some cost. You have your mothership, and then you can deploy these small underwater vehicles to do your research. Let me quickly go through the rest of the slides. And then, having all said all this, there are some unknowns. For example, we are not sure, even though there are models, how the climate change will impact our research. The Gulf Stream, for example, is having wild meanders with increased amplitude, bringing warm Gulf Stream water closer to the continental shelf. That has implications in acoustics. Also in Arctic, which is a big hot zone for climate change and its impacts. We see subsurface ducting, creating a longer propagation into longer ranges that has its own implications by noise-wise. So more shipping means more noise. So for underwater acoustics, that's a problem. And right now we are dealing with another surprise, COVID, and it has its own impact. And we are basically shut down for the last 6 months. And we are planning reopening our cruises, but there will be occupancy limitations in our research vessels and quarantine requirements as well. And then there could be economy sometimes plays a big part. So if there is a recession or a limitation of resources, that will impact our funding and resources. The resources are always limited. But there could be some ways in which you can cleverly manage these things. For example, there is a concept called citizen scientist by inviting and incorporating citizens to help out with research, thereby educating them also, thereby increasing the public awareness. So there is a program in Woods Hole Oceanographic Institutions where they involve citizens in analyzing images of seafloor. And there is another program in URI where they outfitted a ferry which goes from New Jersey to Bahamas with ADCPs, and they thus collected 25 years of ADCP data to understand the Gulf Stream transport. The biggest concern is manpower. I will just read through this quickly. There was a congressional testimony recently in the last year, and one of the leading management person, Mahmood Khan from PepsiCo, he testified that approximately half of the year's workers in industry that have scientific degrees will be eligible for retirement in a decade. And what he said was, we have no line of sight today on how to replace them. So this is acute in our case in ocean-related sciences because of our highly specialized nature, which needs years of experience to get some level of expertise. The multidisciplinary nature for many of our people, it's not a mainstream, their mainstream path of career. So they are coming here mainly because of the passion and also the challenging work environment. So if you see that I cannot recruit, it would be hard to recruit a new student to work on an environment like what I show in that picture. So he will be more interested in sitting in a desk in an air-conditioned office and make a lot of money. So the bottom line is we need to cultivate passion for the ocean in early student life. And that's my last word here. Finding ways to inspire and empower the next generation of scientists, conservationists, and citizens in our changing world is among the most important thing that we can do. So while I wish Dr. Atmanand the well-deserved retired life, and I hope that he will continue to preach the gospel of ocean sciences and its virtues in many more years. Happy retired life, Dr. Atmanand. Thank you.
Thank you very much, sir. And it is a very nice topic related to present requirement of AUV and other acoustic related work, which is now even that bathymetry nowadays, saltwater bathymetry or EZ bathymetry, which is required a lot of unmanned and autonomous vehicle, like what you have presented recently, which is in very demand now. So thank you very much. So in the next, I'm going to welcome Dr. Hanwant Singh for next series of lecture. So Hanwant Singh has received his PhD degree from a joint program from Massachusetts Institute of Technology and Woods Oceanography Institutes. Currently working in the Northeastern University College of Engineering, USA, and in the different capacity. He is a professor in electrical and computer engineering and joint appointed as a mechanical and industrial engineering and program director of Master of Science of Robotics. And his research focus are robotic sensor, system platforms, algorithm, and high-resolution optical and acoustic sensing, underwater vehicles like AUV, ROV, towed and unmanned vehicles, unmanned surface vehicles, and unmanned aerial systems, and so on. And he has the member of various society like IEEE, then American Geophysical Union, and other things. And here I welcome him to deliver the lecture, sir. So please go ahead with your lecture.
Anu, you are muted.
I will unmute it, sir, and make it full screen also, the PPT. Please unmute. Yes, coming. Yes.
Can you hear me now? Yeah, okay, great. Okay, thank you all for inviting me to this talk. And I'm going to start in a kind of inverted way because I'm going to thank you first, Dr. Atmanand, for being the person that you are. I know you have visited us in Woods Hall, and I've had the pleasure of having you over at our house. But when I was first invited for this, I felt a little uncomfortable given how much you have done, not just in research but also for the community, and so I am really honored to be here today. Okay, and I don't know your family, but that's okay because I think everybody in this seminar is part of your extended family. So from your extended family, we thank you from the bottom of our heart for everything you have done for us. And even though you're retiring, we will not let you retire very easily. We hope to keep continuing this collaboration that we've always had with you. Okay, having said that, I'm going to talk a little bit about one aspect of my work. I work on all sorts of things. I've worked on imaging underwater with archaeology, with AUVs, with surface craft, and with aerial vehicles. But what I thought I'd do is talk really about one thing, which is the seabed AUVs. And this is a class of AUV that we developed in our lab almost 20 years ago. We first developed it. Unlike most AUVs, it is not a torpedo shaped. Most AUVs are torpedo shaped because we like to say they were funded by the Navy, and the Navy likes torpedo shapes. But instead of working in the mid-water column, we want to work close to the seafloor. So when we designed this vehicle, we designed it to be a helicopter, essentially. So people often used to ask me, how fast does your AUV go? And I would always respond by saying, we can go very slowly. We can come to a complete halt. So we can really take very high resolution images of the seafloor. And, when we built it first, we built it for ourselves. And one of my students was leaving for Australia. He wanted to use it there. We built another one for him. Then we worked with some people at NOAA. They really liked it. We built another one for them. And slowly over the course of years, we have built more than a dozen of them, and they're all over the world. One of these years, we have to get one in India to use, and we've been talking about that for a while. And part of the basis of building these vehicles is to actually, try and get really high resolution images of the seafloor. And there are lots of issues associated with that. Some of them include the fact that lighting is hard underwater. And so especially when you're from an AUV and you're limited in terms of power, so you can see the images on the left. And then not just the lighting, what also happens is the attenuation of the electromagnetic spectrum means that all images tend to look green or blue. They don't have what we call true color. And then as we move away, there's the whole concept of backscatter. So if we look at the middle images, this is an ancient shipwreck in the Mediterranean. The top image is taken from 3.5 meters away. The bottom image is taken from 11 meters away. The water has not changed, but the small suspended particles in the water make it look like we're driving in fog. And then we also have all sorts of other interesting issues about how to put these images together. So we worked on this problem for a while, and one of the things we did, for instance, was to say, look, can we take these images and get true color imagery out of them? And basically, what we wanted to do is say, something very simple. Let's take the world's oceans, let's drain them, let's look at everything that's on the seafloor with sunlight, and then how would it look? And of course, as opposed to draining the world's oceans, because we're not physical oceanographers, we decided to do this in signal processing. Okay, and it seems to be working really well. So a lot of the images you'll see in the successive slides have been corrected in this manner so that we can actually do some really nice work with them. Now, let me give you one example of the kind of work we're doing. We were working with these fisheries folks. They from NOAA, which is the government agency that's responsible for fisheries stock assessment. And one of the things they said is nowadays to set fisheries quota, we actually go out and catch the fish. And when they catch the fish, they're actually, almost reducing the catch by going out and catching it. And their big deal is to say, can we do something which is fisheries independent? Can we count how many fish there are on the seafloor without actually catching them? And so one idea was, let's take this vehicle, we'll drive it along the seafloor, we'll take lots of pictures, and then we'll count the fish in those pictures and see if we can say something about the health of the fisheries. And there are all sorts of problems with that, and I'm going to just talk about a couple of them. Here's one problem. Even though we have color corrected this image, you can see this skate is kind of camouflaged in the middle, right? Now, what's interesting is if you looked at the original image, you wouldn't be able to see the skate. But what's even more interesting is, even though you guys all look at this picture and you can see the skate, there are actually two skates in here. And so, Dr. Atmanand, I apologize. I know you are retiring, and one of the things I always tell my kids is, especially growing up in the Indian system, I was always afraid of examinations. Okay, my nightmare right now is that I wake up and it is my Hindi exam, and I've actually prepared for my mathematics exam. Okay, and when I wake up, I tell myself I'm a professor. I give exams. I don't take exams. So now, Dr. Atmanand, you are retiring. I apologize, but there's going to be a slight examination in this talk, okay? So I know all of us can see this single, and I'm giving you the first question because it's an easy one. We can all see the skate right here. Can you see the second skate in this image? And I'll show it because I told you this is an easy exam. It's right here. I don't know if you can see my cursor. It's right on top. So this is one problem. Here's another problem. And so there you have, the problem of animals being camouflaged. And so here we have an octopus. This is a video taken by my collaborator, Roger Hanlon. And we're going to show this to you in slow motion and reverse. And I often show this, I'm a computer scientist as well. I often show this to computer scientists, and they say, wow, this is a great simulation. And I say, no, it's not a simulation, it's real life. And that is the wonders of the ocean. So the big question is, how is this octopus doing all this? And can we learn something about this? So now here's the exam. And this is an exam for all of you. I'm going to show you the first one. There's octopuses hidden in all these images. Okay, and there's an octopus right here. The first one I'll show you is right here. You can see its eyes. Can you see my cursor? Everybody can see my cursor? Yes. So there's the eyes. You can see its arm right here. So here's the octopus right in here. Okay. And now I'm gonna pick on some of my friends who I happen to know are in the audience. So Renee, can you hear me? Professor Agreo? All right, Vinu, can you hear me?
Yes, I can.
All right, Vinu, you're on next. In the second image, can you see the octopus? All right, I'm going to show it to you.
No.
Okay? Vinu, I think Dr. Atmanand is going to do better on this quiz than you are. But here's the octopus. You can see my cursor, and you can see its eye right here in the middle.
Yeah.
And what's interesting about it is it's not just blending into the background. It's building up a texture, which is like the texture which is in the rocks and the coral right there. So it's not like the skate. The skate was just burying itself in sand. Here, this thing is actually, figuring out the family of textures that exist and trying to make one up that it can on its skin. Okay, so now, Renee, I see you're out there. So you're on next. Can you find the octopus in this third image?
In the middle, beneath the
very good, very good.
Looking
so
like a cactus.
See it right here. Is this it?
Yes, exactly. Yeah.
Yeah, you can see the eyes, and you can see that. I'm impressed. Have you seen my talk before? No.
I'm a diver, so
okay.
I'm used to go there.
No pressure. Can you find the octopus in the last image? And this is NIOT, so I will let any NIOT scientist also help Dr. Atmanand. And this is an unfair question. I have to say that already, Dr. Atmanand. So
in the middle, somewhere in the middle.
No, I'm sorry, not in the middle. I had kept all of them close to the middle in the other images, but this is the hard exam. So, because you're retiring, it's the last exam you're going to take in your life.
Haro, is it off the right top corner?
No, I'm going to give it away, okay? Because in the interest of time. So there's no octopus in this last image. This was the last choice. So I apologize, Dr. Atmanand, but I had to have some fun with you. Okay. So, but the point I am trying to make, which is a serious one, is that for objects like this, a lot of fish are camouflaged, and if you know they're camouflaged, you can always see them. But they occur so so infrequently that if you don't know it's in the image, it's much harder to spot. Okay, that's one very quick thing I can do is now in this case, here's another image. You can see the octopus in the middle. I like to have problems like this because when I first saw this problem, I thought it was an impossible problem. Okay, so I have an impossible problem. I keep it in my back pocket. I show it to everybody I know so that we can collaborate on it. And I showed this to one of my friends, now friends, Lakshman Prasad from Lawrence Livermore. And he said, this is a great problem. And he came and we worked on it for a summer. And we actually solved this problem, which is kind of cool. So, and I'll show you how we did this. So here's the octopus right here in the middle. We did some image processing to do very high segmentation. Now, this doesn't solve the problem. We can actually segment the octopus. It is segmented, but we don't know which segment belongs to the octopus, right? And then it was Lakshman who had a very nice intuition grasp, and suddenly you can see the octopus is segmented right here in the center. You can see there's some false positives along the edge. Those are actually easy to filter out. And in the interest of time, I'm just going to, usually I have people try and guess what we did, but I'm going to tell you what we did. What we realized is that octopus, because all these things are corals around it, but the octopus, because it's an organic thing, tries to conserve heat. So its outline is much smoother than the outline of all the plants and the rocks that are around. And that's why we're getting these false positives, because they have this straight line on the edge and they're easy to filter out. So again, it was a hard problem, but it was a kind of cool problem, which I thought you'd appreciate. I'm going to jump out a little bit now at the higher level. And, when we look at fisheries, it was all, initially the thought was, hey, if you can go and take pictures, then we'll be able to count how many fish there are. But the problem always was that, fish are like people in front of a television camera. Okay. Some of them, they see a television camera and they say, oh, television camera, and they run towards it to get their picture in the television. We call that fish attraction. Some of them run away. They say, television camera, I don't want to be on TV. They run away, and that's avoidance. And some, they live in Bombay. They say, oh, television cameras all the time, no problems. And those are the kind of fish we can actually measure. So to make sure that we don't have biases in our measurement, we try and figure out what the avoidance and attraction behaviors are. And we just did this big experiment with NOAA, where we put some cameras on the seafloor and let the fish get habituated to them. And then we ran different kinds of vehicles past them. We ran a ship, an ROV, towed vehicle, and an AUV to see, we'd see them in the movie and we'd count them from the vehicle, and we could try and see what the differences were. And so here's a simple movie, and I want you to just watch it and tell me if you think there was avoidance or attraction behavior in this. And you can see the robot going by, and it's a very short movie, so I'm going to play it again, just so that you guys have. So let's try it from start again. Okay. And, I look at that and I say, yes, there was avoidance. And the fisheries people look at that and say, no, there was no avoidance. So there's some interesting little issues right there, which we still need to figure out. Okay. All right. Let's move on a little bit. One of the other things I've been doing in the last decade is really working with at the poles. We like to say we are bipolar. We have worked in the Arctic and the Antarctic. Over the last 15 years, we have done almost 20 cruises there. And I just want to show you a little snippet of data. And I know Dr. Poti talked about manpower and how to get students more involved. And there's nothing more fun than taking our students out to the Antarctic. In this case, we're out with the Australians, and they really enjoy and love the adventure of doing this. This is my ex-student Clay Coons. And of course, instead of continuing in the ocean, he's now working for Google on autonomous cars. And that's one of our big problems. Our good roboticists wind up in industry. And the other person you saw in that video, he's Dr. Peter Kimball, and he is also working for Google, but he's actually working in an ocean-related project, which is kind of nice. So this is the Jaguar vehicle, like I said, being deployed to study sea ice. I just wanted to show you this video to get a sense of what's going on. Typically, we don't have good underwater video because we go to 4,000 meters or 2,000 meters. And but in this case, we were just going only to 35 meters and looking up to map the sea ice. So we had a little GoPro camera on the vehicle so that we could actually see what was going on. And then we got lucky. There was a little ROV there. and it got this beautiful shot of our vehicle going under ice. And again, we've worked on this stuff quite a bit. This was work we did both with the British Antarctic Survey and the Australian Antarctic Division. We went to different parts of Antarctica and looked at how sea ice is changing out there, and it's been some really nice work. And and then coming up even more, I think one of the big issues that's happened in our world with our EUVs, for instance, is 20 years ago we were data poor. We didn't have enough imagery of the seafloor. And then suddenly, literally, we have millions of images. The Australian vehicle has more than 1 million images in its archives of coral reefs all around Australia. Our vehicle has 500,000 images. The NOAA vehicles have more than 1 million images. And and the first time they see these images, they say, not only are these images very good, but they are also, we have so many of them and they are fantastic images. And then they say, oh, what do we do with them? Okay, because normally they would work with them on hand if they had 100 images. With 1 million images, you just can't do that. So a lot of the images just sit in an archive. And now recently, we've been starting to work on machine learning. We did it on lots of things. We went out with drones and found a penguin colony which had 1.5 million penguins. And the biologists counted each penguin by hand. And it's kind of scary because if you count to 1 million and take 1 second for each count, it takes 11 days. Okay, it's a lot. And so hats off to them. And then we had one of our grad students who looked at them. He had collected the data and he said, I'm going to write CNN to do this. And turns out his numbers were just as accurate as the 3 biologists who counted them all by hand. So I think that's the kind of good stuff that's coming down the pike. We were data poor. We're now data rich, and now we want to go from being data rich to information rich, which is, we really, yes, we care about the images, but we really want to count how many penguins there are, how many fish there are. And that's what's important. And I think that's what's coming down the pike. The other thing that's coming down the pike is, manipulation. We've always done that with ROVs, but we've done hydraulic manipulators. Instead, we'd like manipulators that can pick up eggs and then actually have the strength to actually work with them. And so we have funded projects to take these what we call haptic manipulators. If you want to thread a needle underwater, we could actually do that. And that's some of the things that's coming down the pike, some of the new technologies. I'm going to end it right there, and of course by acknowledging all my students who do all the work, and more importantly, wishing Dr. Atmanand the very best. Thank you, sir, for being who you are, and we really appreciate it.
I think before concluding, I would like to thank both of them, Dr. Gopu and Dr. Hanu, for being awake at this odd time and participate in this meeting. Really, thank you so much. We appreciate. Thank you.
Thank you.
I thank both the speakers. Really, it is a great pleasure to have you here, and thank you very much for accepting. And now at present you are in US, and the time is very, very early morning. Maybe you might have got up 4 or something to prepare this time. So we, from organizer side and from my side, I thank you, both of you, to having and providing us a very good information about recent technology. Thank you, sir.
Thank you.
Now I just say a few words to Dr. Atmanand, sir. I am glad to work with you, sir, from maybe more than 2 decades, and thanks for your valuable suggestions on time to time when we need on various technical and administration issues. And you are really instrumental in forming this staff recreation club of NIOT, and which is very well going on till date, and helping in other society like IEEE, OSI, MTS, and all. So your suggestions are valuable, and it is going very well. And we also wish for your good health and contribute more towards the ocean science and technology and your support to decades to come. Thank you, sir.
Thank you, Dr. Jaina, for handling session. I now request Dr. S. Ramesh, Scientist G, NIOT, to introduce the speakers of the next session.
Good afternoon to all. It is indeed with great pleasure to introduce three eminent international speakers on this session for the workshop on recent advances in ocean science and technology to honor Dr. M.A. Atmanand, Director NIOT, on his contribution for the period of time. So with this, first speaker for this session is Dr. Venugopalan Pallayil from National University of Singapore. He is basically a physicist with a doctorate in microwave electronics from Cochin University of Science and Technology, Cochin. He joined as a scientist in Naval Physical Oceanography Laboratory in 1986 and contributed to the Indian defense in the field of airborne ASW systems. In 1998, he moved to Acoustic Research Laboratory in Singapore as a research fellow, and presently he is serving as deputy head of that division. He has been responsible for the successful completion of many projects, which includes ambient noise imaging systems and time reversal mirror and digital thin line towed arrays. The project on Romanis had won a prestigious Defense Technology Prize for the group in 2004. He has several publications to his credit and have international collaborations, including seabed characterization experiment with Woods Hole Oceanography Institute. Dr. Venugopalan is a senior member of IEEE, member of Acoustic Society of America and Society of Acoustics in Singapore. He has served as a local IEEE Ocean Engineering Society in various capacities, including chair, vice chair, and treasurer. He also served OTC Asia Conference in various capacities, including chair in 2018. He won IEEE OES Presidential Award in 2018 for his exemplary services to the society. Currently, he is leading the research activities on the development of lightweight towed arrays, including fiber optic arrays for underwater applications using AUV and unmanned surface vehicle platforms. With the close interaction with our director, he is a regular visitor to NIOT for collaborative work in the areas of acoustics and also characterizing the manganese nodule for the acoustic imaging with impedance contrast for deep sea mining applications. So on behalf of our organizer, we welcome you, sir, with thanks for readily accepting our invitation to deliver this valuable talk. Please, sir.
Can you hear me?
Yeah, sir. Clear.
Okay. Thank you. And on my list, actually, it was supposed to be Dr. Vijaya Ravichandran. But thank you, Ramesh, for the nice introduction.
She's not well, sir, so that's why I just talked.
Okay. I would also like to thank Dr. Ramdas for inviting me to be part of this one-day workshop being hosted in honor of Dr. Atmanand. I'm sorry that I did send a CV, which is just maybe 10 lines, which possibly did not reach you in time. Sorry to bore everybody with that long description. And before I begin my presentation, I would like to say a few words about my acquaintance with Dr. Atmanand. Though I knew Dr. Atmanand, perhaps it was possibly in 2009, I think I happened to meet him in person because my son got enrolled in Chennai IIT for his undergrad, and I used to travel from Singapore to Kochi via Chennai. And during one of the trips, Dr. Dilsha, who is my another colleague, invited me to give a talk. So after that, I got to know him better. And when he became the director of NIOT, I started discussing with the possible collaborations with him. It was not easy, but in 2018, we managed to do a joint experiment with NIOT, and I'll be talking about that experiment. So I will be moving into a laboratory setup, as Gopu was mentioning. Maybe that may be of interest to young graduates because you don't have to go to sea. Actually, in my institute, I have non-oceanographers who have been simulating sea all the while on computers and never been out at sea. So I think we can still survive. So I have been visiting NIOT now and then, and I had the opportunity to be part of UT 50 and the NIOT Silver Jubilee celebrations, which were organized under the leadership of Dr. Atmanand. Apart from the technical collaborations and stuff that we did, we both have been deeply involved in the IEEE Oceanic Engineering Society activities. And I'm currently working with him to host, Chennai is hosting the Oceans 2022 conference, and I'm a liaison to make it a successful conference. And all the while, I have found him very highly energetic person, and very pleasant and easy to interact with. So his local and international outreach is actually well evident from the line of speakers you see today who have agreed to be part of this one-day workshop. So I take this opportunity to wish him all the best, which I would like to term as a new lease of life. But at the same time, I feel a bit sorry for him because I didn't know that. Being a director, he had to go through this one-day workshop, sitting all the time, looking at your monitor and listening to some of them. It is an informative talk. And so with those words, I would like to go to my presentation. Okay. So can you see my screen?
Sir, it has to be projected, sir. It's coming in a bunch, actually, one by one.
Using a PDF, so.
Ma'am? Okay.
Okay.
Yeah, fine, sir, fine.
Okay.
That's fine.
So I'm going to, so this is a collaborative experiment which we did with NIOT, as I said, and actually this took off because at that time, I think Atmanand was not the director of NIOT. So, but again, when we really started the experiment, he was again back as the director of NIOT. So a little bit of background information. So as many of you are aware, the International Seabed Authority actually allocate certain areas in the Pacific Ocean for if they have an interest to go and explore the polymetallic nodule. So in 2015, Singapore got about 58,000 kilometers square allocated for exploration. You just may want to know that Singapore is about 720 square kilometers in size. So you can imagine how many times of Singapore size have been given for this exploration. So we did a couple of cruises. Anyway, I was not part of this program because I initiated this collaboration. I thought it is fitting to present this collaboration during this special occasion. And I heard from Ramdas that this is a one-way presentation. So I'm pretty happy because I don't have to answer any questions. So the question we were trying to answer is when you spend a lot of money going out there at sea and trying to scan the seabed, you need to make sure that you're scanning the right part of the sea and where there are enough nodules for harvesting. So some of the techniques which has been used in the earlier times. One is the coring, but it's more like a point sampling. And the way they do is that use a box corer, and they take the sample, weigh it, and then calculate, extrapolate to find out what is the nodule density. They can do multiple coring and then use some algorithms like kriging to get a better estimate of the overall density in that area. But it's, as you know, it's a very labor intensive and highly resource intensive. Optical imaging is another technique. You have heard both Gopu and earlier Dr. Kawasaki and the last talk, Dr. Hanu, all talking about autonomous underwater vehicles. And it has actually, widened the horizon by which you can do the survey of seabed. So you can fit in equipments, optical imaging or acoustic imaging equipments, such as side scan sonar and multi-beam sonar. And you can move through a large area of seabed in a short time. Actually, it is autonomous, so you don't need any human intervention once you deploy the system. And some of these AUVs can last for 3 days. So you can actually cover pretty large area of sea by using autonomous underwater vehicles. So in our deployment, also we used AUV for the surveying the area under in that Clarion Clipperton Zone in Pacific Ocean. And we collected some data. We also had both optical and acoustic. It's a side scan sonar image. So the question that we were trying to answer is that the issue with the optical is that even though it gives you the resolution, the footprint is pretty small. And the issue with the side scan sonar is that you get a larger coverage because you need to operate at a height good enough to get a larger coverage. So that will make, then your resolution suffer. So the idea here is that with the optical image, can we draw some correlation between the optical image and the acoustic image? And then you can use an artificial neural network to classify those images as where the nodule density is a certain percentage. If it exceeds, say in our case, if it is 40% nodule coverage, we label it as output 1, and if it is more than 40%, you can label it as output 2. So this particular approach has been working to an accuracy of 85%, according to the person who has devised the algorithm. So you can see at the bottom, this is L.J. Wong, who has done this artificial neural network-based classification. So we thought of getting more data to improve this algorithm, but you can't go back to Clarion Clipperton Zone all the time to collect more and more data. So is there a better way of doing things? Can we set up some laboratory scale experiment to know how well this the acoustic sonars can do this classification? So with that idea, I talked to Dr. Atmanan because I knew that NIOT has been doing a lot of work in deep sea mining. And in fact, I saw a paper by them. They made artificial nodules that is primarily to test their vehicles for harvesting. But my idea was to use that artificial nodules. If it matches in density and roughness, then the backscatter that you get from the acoustics can somewhat match with what we what you get with the real nodules. So with that idea in mind, I approached Dr. Atmanand. And this was a kind of a setup I had in mind. So basically, you have to have a tank And at the bottom, you need to lay out the bentonite, which is the deep sea sediment. And then on top of that, you place all the nodules. And then you have moving arm fitted with a multi-beam imaging sonar and an underwater camera so that you can simultaneously capture both the acoustics and the optical images of the nodules. And then the idea is to compare the optical image and the backscatter returns from the nodules and see that we can really get any information about the nodule density. So we used a Tritech Gemini 720i multi-beam imaging sonar, which has got a swath of 120 and a vertical directivity of 20 degrees. So I have covered this. So this is the tank facility. So where you see the polymetallic nodules are being laid out in different, so some of them, this is called the uniform distribution. Then you have a cluster. Then here it is the artificial nodules. Because one of the other things we had the problem was that even though we had some nodules, it's difficult to transport them across countries because there are always restrictions in transporting this kind of minerals. So we knew that NIOT has recovered some polymetallic nodules from Indian Basin Ocean, and they have got this tank facility, which was built for a different purpose, but Atmanand took me to Anna University, where they have built this special tank. And we started to do the experiment in that particular tank. And I got the artificial nodules also fabricated. It was a Chennai-based person who was doing this artificial nodule fabrication. So this is a kind of a layout which we used. So basically, you have the PMN or the polymetallic nodules. These are the real nodules which they have harvested from Indian Ocean Basin. And these are the artificial nodules which we fabricated with the help of NIOT in Chennai. Then we had different configurations, like this is a uniform distribution of the PMN, this is a cluster, and this is again a uniform but a different density, about 7.5 kilogram per meter square. I think this was hard work for both NIOT and Anna University. They helped me to set up this experimental setup at Anna University. And we also placed some, small strip, and these are reflective strip, and these served as indicators as a reference for us. For example, you know that after the second strip, it actually starts the uniform distribution of the EMN with this coverage. And similarly, at the end, we know when we reach here, this is the end of the scanning. So this is just to aid the image processing. So this is a photograph of the distribution of the PMN nodule in the tank. So you can see that the visibility is not that good. This could be even worse, in actually deep sea, unless you use, here we didn't use any proper lighting mechanism initially. So this is the image processing pipeline. Again, I am not the person who did the image processing, my colleague. So our interest was to see the backscatter energy. So we want to just look at the grayscale. And in order to avoid the noise coming from the sides, we confined ourselves to a 20-degree beam width. And then the nodules were placed such a way that about 5 centimeters of the nodule was projecting above the bentonite and 2 centimeters below that. So we cut the image to that size for images, for the backscatter returns that we expect from the nodule covered areas. And for the bentonite itself, we took about 2 centimeters of the surface, below the surface. So this is a picture which shows, this is a separate experiment we did. So we had a basin with bentonite, which we lowered, and then we scan it using the multi-beam sonar. And this is the image that we got. Then we spread the nodules on that, on the uniform distribution. And then we looked at the returns, and we can actually see the presence of the nodules, even though you can't exactly tell the density. But this was a preliminary experiment, and the idea was to see whether we, if at all, I mean, is it a feasible solution for us to continue with future experiments. And these are some of the other observations. So you can see that the mean intensity that we got from the backscattered energy, acoustic energy, with no nodules, the mean intensity is pretty small as compared to the intensities with the nodules in place. So that gave us an indication that it is possible to identify the presence of nodules. There are still some anomalies here. So if you look at 50 kilogram per meter square PMN uniformly placed, the intensity is higher than for a 50 kilogram per meter square with artificial. So the question was whether I can replace these real nodules with artificial nodules. In that case, I can do this experiment without going to any other place. But this discrepancy, we see that if you look at the earlier pictures, the distribution of the nodules, the PMN nodules, which we recovered from the Indian Ocean Basin, had a uniform distribution, and they are of the same size. So we had more numbers in an area as compared to the artificial nodules, which were larger in size. And to create the same density, we have to place them slightly apart. So we didn't get that much of illumination, probably, area of illumination. That probably gave us this difference. And so with we concluded that the MPIS backscatter data allows us to distinguish seabed area populated with PMN, which potentially allows us for additional features in our data-driven approach. So we can feed this information into our already existing algorithm and see whether it can give me better results. So we also saw that the artificial fabricated nodules are good replacement for PMN for the purpose of identification of the nodules on ocean basin. So that's all I have to share with you today. I'm sorry that because I've been preoccupied with a lot of things recently, so I didn't get much of, or rather my priorities were a bit different, but I couldn't say no to this when Ramdas approached me because Atman being such a good friend to me, and I couldn't say no to him. So I just put up some slides which my friend given to me. And thank you again for inviting me to give this talk.
Thank you very much, sir, for your nice talk on the backscatter images using the manganese nodule, which is also a critical one, which we are looking into it for the mining point of view. So it is an experimental setup with the details, how to understand the backscattering and data processing also you explained very clearly. So thank you very much for your time and being available with us and share your experience with Dr. Atman sir also. Thank you very much, sir. So we will now move on to the next topic, next speaker. Next speaker of this session is Dr. Vladimir Ryabinin. He is the Executive Secretary of the Intergovernmental Oceanographic Commission, IOC of UNESCO, and Assistant Director General of UNESCO. Dr. Vladimir Ryabinin is basically a marine engineer with a PhD and further to it with the academic distinction of Doctor of Science in 1995 from Russia. In 1980, he started to work in Hydrometeorological Center in Russia, occupying positions from junior researchers to head of the laboratory. He served as executive director of the International Ocean Institute, and in 2001, he joined the World Meteorological Organization as a senior scientific officer, World Climate Research Program, contributing to the international coordination of climate research on polar, ocean, cryosphere, stratosphere, and atmospheric chemistry. so with a wider spectrum of the understanding. In 2017, by a presidential decree, Dr. Vladimir received a distinction of Emeritus Meteorologist of the Russian Federation. He specialized in studies of turbulence in stratified fluids, the ocean circulation thermodynamics. He is one of the key contributor to the first technology of medium range, that is weekly time scale weather prediction in the USSR in 1980s. So he was instrumental and originator of several mathematical models for ocean, atmosphere, wind, waves, etc., and an author of hundreds of scientific publications. And after his arrival in IOC, the Commission proposed the idea of UN Decade of Ocean for Sustainable Development, that is 2021 and 30, which we are running now. So now the implementation plan for the decade was also submitted to the consideration by United Nations General Assembly. So he is very closely associated with our director in many international meetings under Intergovernmental Oceanography Commission of UNESCO for giving direction to the global scientific community towards ocean observation, meteorology, and so with these few words on behalf of organizer, so we welcome you, sir, with thanks for accepting our request to deliver this very valuable talk. Thank you very much. Please.
Thank you. So, it looks like it is a kind of a distinguished career, but I think I'm technologically challenged. So may I ask you if you see my screen?
Yes, sir, it is there. It has to be zoomed.
Okay, good. So then I will just make it into a presentation.
Yeah.
So now you see it all, right?
It's nice, sir. It's nice. Thank you.
Okay, so, and this is exactly the title of this talk. One ocean, one planet, and there is only one person on the planet. I think that really is so special and also dear to me, and this is one Atmanand. So, my talk is now to honor my friend Atma and to move forward on certain things that will definitely remain between us and between us all in the oceanography. But I think it will be useful if I introduce to you a little bit the Intergovernmental Oceanographic Commission of UNESCO. That is the home of ocean science in the United Nations system. And we are a part of a big organization, United Nations, UNESCO, Organization for Education, Science, Culture. Sometimes I believe that the last letter in UNESCO stands not for the word organization, but for the word ocean. I think we have to aim for this. So 150 member states, and this year we're celebrating our 60 years anniversary. So this is what we do, very briefly. So we coordinate research. Then we also coordinate global ocean observations. Observations are turned into data. The data are used to and science and knowledge to provide services, like, for example, tsunami warnings that are so important, as unfortunately live showed for the Indian Ocean. And of course, also this data would be very important for different types of assessment of the state of the ocean. The whole sum of knowledge helps. I don't know what is. There is an echo. Maybe ladies and gentlemen can just mute some of your microphones. So at least I do it for myself. So and then but this is all not what we do. We are creating conditions for development of capacity. So this requires education and communication. Huge, of course, scope of activity, but this is what the world needs in oceanography. Just an example, a small example of what is organized by IOC together with Scientific Committee on Oceanic Research and Indian Ocean Global Ocean Observing System. This is the Indian Ocean Expedition 2. That is now continuing until the year 2025. What is so special about this? I see Shalish joined, so that's very relevant, I think, what I'm doing. Hello, Shalish. So, so this is actually one of the first things that IOC did back in the 60s. And now we're having the second reincarnation of that expedition. More than 30 different projects. But this is just a research exercise. We need to converge all this exercise into something really doable. So, and also we work in the regions. You see the slide here, which shows four big regional groupings of IOC: in Western Pacific, in the IOC Africa, in the Caribbean, and right in the middle you have this green area that around the Indian Ocean. This is the IOC India, a regional committee for the Central Indian Ocean, and Atmanand, Dr. Atma, is actually the chair of that commission. So this is what brought us together, and you see some familiar faces. And I have to say that right now, I see Shales, I see Atmanand, also Justin Hanhansa, who is number 3 from the left in the first row, is there. But I would like to highlight to you 3 people here. So first of all, this is Atma himself. The second person is me, and the third person that is also has this little oval around the face is Stephen Hall. At the time, Stephen was the vice chair of IUC, like Satish, who is seen to the right from Justin, number 4 in the first row. So he was the officer of IOC. And the first meeting for me of IOC India actually was the fifth meeting of this regional committee of India, took place in Chennai. So Atma definitely immediately invited people to National Institute of Ocean Technology. And Stephen Hall, who is now who has been running the Society of Underwater Technology, of course, was very happy to go there. So unfortunately, I couldn't do it, and this remains my dream to be to visit your institute. Hope that soon we will be able to travel. But so after that visit, Stephen came back, and he said to me, Vladimir, I don't know. Where is now the lead on ocean technology? Is it in the West, or it may be in India? So this is for me a very important statement that, India is a true leader, and also because of the work of the National Institute of Technology in this particular field. So I congratulate on that. So now IOC India. So, we'll see IOC India is getting bigger and bigger and bigger, and this requires, of course, a lot of investment, mental investment, time investment, and we have this from Atmanand and the community. I think I have to confess that after I finish this talk, and tomorrow, this is Saturday, this is where we work at home, so I will keep working on the IOC India document to prepare for you the rationale for turning IOC India into an IOC subcommission, then increasing the powers of that body. So that is what is uniting us with Atmanand. So now a big thing that is happening around the world that IUC also starting is the Decade of Ocean Science for Sustainable Development. So, it's going to be probably the largest campaign in environmental sciences. And also Atma is at the center of the design of this, because he is the member of the executive planning group, always, acting as a gentleman, wearing a pin of India on his jacket. So this is the executive planning group at its best. We had a meeting yesterday, and we're moving forward with the Decade of Ocean Science. So why do we do this? This is really important, because the Decade of Ocean Science, the full name is United Nations Decade of Ocean Science for Sustainable Development. And every word matters there. Sustainable development is very important. It's not only about this little bit twisted Sustainable Development Goal 14, because we need to speak about food for people, for energy, climate, education. So this is what this is all about, and how ocean translates into all these areas of work. As you can imagine, this is a huge area, but the ocean now is in crisis. And in 2016, this was the first, I think, the most important statement of the first ever United Nations World Ocean Assessment, that the humankind is running out of time to start managing the ocean sustainably. So a very strong statement. And I think we need to move forward and engage the potential of science to help the ocean. So, but of course, now we are all mostly sitting at home, and the world is preoccupied with the coronavirus, a very, I would say, terrible situation. But I think for me, the lesson there are many lessons about the empathy between people, our philosophy that is actually getting, I think, more appropriate for the state of the earth that we live in. But one of the lessons is the power of focused science. It is the science that now needs to help this humankind to find a better path for sustainable future. So the situation, to me, to some extent, reminds what was happening in the world with the Convention on Climate Change, when in Copenhagen 2009 there was a meeting of the Conference of Parties. The science was there, but the decisions were not taken because the science was not convincing enough, because scientists just thought that they would just deliver the message to governments and governments would start acting. Come on, it's impossible. We need to convince the governments, and if sometimes force the governments to act. So the situation now in the world is, in terms of emissions, as you see on the screen, you see an unstoppable rise of the emissions. And then, surprise, surprise, we have this huge drop. And of course, because we are confined, because nobody can do really anything. So, and now there is a big dilemma. What is going to happen after the coronavirus? Because I yesterday participated in a meeting, and the prime minister of a small island state, Santa Lucia, said that, we are now collecting only less than 50% of taxes. We need to run the country, and still the energy that is produced by renewable sources is more expensive for us than the dirty and cheap oil and coal. So now that the world is in a very difficult state, and the technology is really needed to take us out of the crisis and a new level of understanding of where the world is going. So that is exactly the paradigm that we're trying to develop in the domain of the ocean through the decade. And the main idea is that we have to observe the ocean, to understand better the processes there, to be able to predict the state of the ocean. And with that, we will be able to manage the ocean scientifically. But importantly, it is a paradigm shift that we cannot just do it from the countries that are technologically developed, like the Western world, like India. You will see this little map of the world, and there is no Africa there. Africa cannot be, keeping pace with the technological development, published on the level that we do. So it has to also be a capacity development exercise. So moving forward the science, towards integrated ocean management, and leaving no one behind is the main idea for the decade of ocean science. And then management that will be required for the ocean, integrated ocean management, involves coastal zone management, maritime then with the fewer number of areas, or with the smaller area, we'll be able to still recover the ocean, management of fisheries, work on the climate change. So there are many areas where the science and technology are needed to keep this planet populated by our species, actually. So, and then in terms of what we need to do with the science, I would like to just offer to you one opinion. I think some people started to repeat this my slide. I'm very happy about that. But the main idea, for at least I see this, our science is historically based on curiosity and now able to alert the world about certain problems. But the science needs to be also oriented towards solutions. In terms of observations, we have already competent system for climate and physical parameters, but we need to extend this to many parts of the world, including polar areas, deep ocean, add biogeochemistry, add biology, and turn this into a digital twin of the ocean. And we have the society that, of course, lives on the Earth, but we need to have society that ocean literate, so we can understand what we do with the ocean and have good decisions. So the funding for ocean activities is mostly in research mode, and because of that, we don't really capitalize on the value chain that exists. And ocean science generates a lot of wealth, but there is no return from this wealth to the ocean science to capitalize on that and further develop and make ocean science and derivation sustainable. And the capacity, I already showed to you the slide. So we need to have transfer of technology and capacity development. So just an example, you will see now an image of a surface, and it looks to me that we have several underwater, several submerged mountains. There is a trench somewhere. So it looks to me like a very high resolution map of the ocean depths. But there is a big problem with this image, because this is not the map of the ocean depth. This is the map of Mars. And we know the surface of Mars much better than we know the surface of our own ocean. That is a huge problem. But now I am not cheating. This is the map of the site of the depths where this Malaysian Boeing was being searched several years ago. And you will see already that with the current technology, it is possible to create a map of the ocean that is of sufficiently high resolution. So this is what we can do. So, but you know, this is the area, actually the area to the west of Australia, and the submarine which was used there actually was almost broken because it was unable to operate at the depths that was there. But you know, before that exercise, that particular area looked like this, and this is actually the image that shows the resolution of our current knowledge of the ocean depth. This is based, of course, on gravimetry using satellite topography verification, and so this is what we know. So we must change that, ladies and gentlemen. So. And this is the motivation for the decade. This is where we are. We proposed to United Nations the Decade of Ocean Science. Then they agreed that we have to conduct it, and now we have implementation plan. I would like to thank Atma for his contribution to the implementation plan of the decade. And now we are moving forward. If I'm not mistaken, today is the 25th of September, so it means that 97 days remain before the decade starts. So we like, by the end of the decade, or maybe earlier, to arrive at certain qualities of the ocean, but also people. Clean ocean, people are safe on the coast of the ocean. Predicted ocean, it's not the state of the ocean, it's our state, that we can predict the state of the ocean. So this is the goal. And the main vision for the decade is the science we need for the ocean we want. So this is the ocean we want. What is the science that we need? This is manifested in the decade challenges. So we need to know how to work with the pollutants, how to protect ecosystems, how to feed people, how to move forward with sustainable ocean economy, and under conditions of climate change that is creating actually havoc in some parts of the world because of, say, of tropical cyclones and some other changes. For that, we need observing system. We need to create a digital twin of the ocean, develop the capacity, and change the behavior. So just be ready, please, for the call for action that is going to be out on the 15th of October, and be ready to contribute great ideas about the programs of the decade. And I would like once again to thank Atma, my dear friend, for contributing to where we are. And I hope very much that, you know, in Russia we believe that real life is before school and after the retirement, and the rest is work. So I don't think that real life is starting for Atma now, because we need him back. We need him to lead IOC India, and we need also his input to the decade. So life continues, work life continues, and I thank Atma, and I thank you all for your attention. Take care, everyone.
Thank you.
Thank you very much, sir, for your nice and wonderful talk about IOC Indio and then the recent decade of oceans for sustainable development and its present trend even for the COVID-19 post-impacts and the decadal challenges. So many questions you have been posed to answer by us and the next communities. So thank you very much for the wonderful talk and your association with our director. So we will move on to the final speaker of the technical sessions today. Mr. Justin Ahanhanso, if I am spelling correctly. So Justin Ahanhanso, he is from IOC UNESCO. He is basically a physical oceanographer, and he is presently serving as a regional liaison officer of IOC for Latin America and the Caribbean, Asia, and the Pacific and Africa Intergovernmental Oceanographic Commission at headquartered in Paris. So I request Justin to say a few words. Thank you. Sir, your audio is not coming. Please. Voice is not coming, sir. Maybe you can. We are able to see you, but we are not able to. We are not audible.
You know, Justin, come over. Justin, come over to my place right now, because otherwise it will not be able to hear you. It will take 30 seconds for Justin to come over.
Okay. Thank you. Thank you.
Yeah. Muted. He was muted, so that's why he had to unmute.
No, there was no microphone.
Oh, I see.
Hello. sorry for disturbing the session. I'm very sorry to disturb this important high-level session, but I'm very glad to be associated with this high-level seminar on the recent development of science and technology, and I'm particularly privileged and honored to be able to speak at the retirement occasion of a good friend, who is also my boss, because who is the chairman of the committee that I'm serving under his leadership. And I should say that we have studied all about the future of ocean science technology that we go through the decade. So I will briefly speak about what we have been achieving in ICNDO under the leadership of Dr. Atmar, his colleague in Bangladesh, Dr. Mohammad Uddin, and Dr. Faiza in Kuwait, and under the leadership with the support of the government of the region, in particular India, Bangladesh, Kuwait, and others. ICNDO have been very active from the starting, some 20 years ago, but then it went through a dormancy period. And it is through the strong leadership of Dr. Admanat with the political support from India, and we are very grateful as IOC for the support that the government of India provided to IOC to start the reactivation of ICNDO in 2016. And here again, it is at the NIOT, it is at the NIOT in Chennai that the first reactivation meeting was organized. And from that now, ICNDO is back on track and define a strong work program that is aligned with all IOC major programs in GOOS. And here we have IGOOS, we have NDOOS. And in particular, the ICNDO region have defined two key proposals, one on coastal vulnerability. The first workshop was held at the new UNESCO Category 2 Center in Hyderabad at INCOIS. You know, we have at IOC only two UNESCO Category 2 Centers. And it happened that the two centers are all in the ICNDO region. One is in Iran, and the second one is Hyderabad. we hosted under the leadership of Dr. Satish Chennai, the first workshop in 2019. The recent workshop, together with the regional workshop for the Indian Ocean Decade, associated with Central Indian Ocean region, was again organized last January, early January, at NIOT, with the participation of the Secretary of India. So, from that perspective, we believe that the key area that ICNDO Work Plan present are in line with the decade plan. And from that perspective, we are working towards on a proposal that will be sent to member states and present next year to the IOC Executive Council and Assembly to discuss about the upgrading the ICNDO committee to the status of the subcommission for the region, and probably maybe for the entire Indian Ocean as it was raised at the reactivation workshop in 2016 in Chennai. So that is a brief overview of ICNDO in line with IOC program and the decade view that I wanted to present, knowing that time is short. And again, I'm sorry for the technical trouble with the speaker in my office, but I'm very, again, honored and happy to be associated with Skype level. And I would like to wish all the best to my good friend, Dr. Atmanand. And as we say in Africa, people like him retire, but they are not tired. So as Vladimir said, we need him for ICNDO, we need him for decade, and we need him in particular to build the bridge between ICNDO region and IOC Africa and African region, both in terms of technology transfer and also owing to the historical relation in the Indian Ocean between East African country and the Indian countries. So from that perspective, I'll stop here. I thank you all again, and goodwill and good health for my good friend Atmanat.
Thank you very much, Mr. Justin Ahanhanso, for your nice words and your association with our director and your direction, which the activities which is in progress by UN Decades of Ocean and on the activities on the coastal vulnerability. Thank you very much. With this is the final session on the technical. So in the final session, we had 3 speakers. We first started with the Professor Venugopalan from National University of Singapore. He has given a nice overview of the test setup and then the experimental work carried out with the manganese nodule characterization, and then followed by Dr. Vladimir, Assistant Director General of UNESCO, and then by Justin Ahanhanso. So on the activities of the UN Decade of Oceans are well explained. So thank you very much for all the speakers. Thanks for joining.
Thank you, Dr. Ramesh, for handling the session. With this, we come towards the end of our technical sessions. So now I welcome you all to the valedictory function of today's workshop on recent advances in ocean science and technology. We've had interesting and informative talks by eminent scientists and technocrats in the field of ocean science and technology from all over the world today. Hope all our audiences have benefited from this workshop. So I welcome our guests of honors to the event, Padma Shri Dr. P.S. Goyal, former Secretary MOES, Dr. Shailesh Nayak, former Secretary MOES and Director NIAS, Dr. S.S.C. Shenoy, former Director NIOT and INCOIS, Ministry of Earth Science, Dr. P.S. Nair, former Deputy Director, ISRO Satellite Center, and Dr. M.P. Wagdikar, Advisor, Ministry of Earth Sciences. I welcome you all, sir. I take the privilege to request Dr. P.S. Goyal once again to speak a few words today, sir. Thank you.
Am I audible?
Yes, sir.
Okay. Good afternoon to all of you. Let me first thank all organizers for calling me for this valedictory function for this very important occasion for the NIOT. NIOT is one of the premier institutions of this country, the only institution that needs tackles with the ocean technology, and it is a big mandate for the country, starting with the services and the technology related. And in last almost 97 onwards its existence, it has done wonderful service to the country. When we talk of the blue economy or we talk of the safety issues with respect to its role in the tsunami warning, its role in the various atmospheric measurements or the ocean measurements, everywhere the NIOT has shown its presence. And out of these 23, 24 years, Dr. Atmanand has led the institution for almost 1/3 of its time, which is very significant. What we see over the last 2 years is a kind of a assimilated growth in main three areas which are very important for NIOT. Number one is the so-called relevance to the society, and there are various dimensions. I'm not going to elaborate, but NIOT has really shown its presence, whether it's a coastal protection or safety against various disasters everywhere, and NIOT has shown its presence. Second important thing is pursuit of technology. I would say even for technology's sake, when we look at it, it has done a wonderful work with respect to ability to go almost, let's say, to the bottom of the ocean in the deep ocean, whether it is 5 kilometer deep or 6 kilometer. That kind of a technology it has developed. Not one technology, various types of technology. In terms of Atmanirbhar Bharat, it has created a lot of new initiatives, new technologies. I mean, when I remember when I first visited 2005, we were doing a very good job, but the technology development internal was not that much. And I remember when I talked to Dr. Atmanand that time that we must do that. He has taken very seriously. He was head of the instrumentation group. And today, a lot of things are coming within the country. The third element of an institution like NIOT is an autonomous body. It depends on the full support from the government. And many times it happens like what is happening because of the COVID today. That particular support is not available in the sense that with 40% cut all the money, so you have hardly anything other than salary to survive or to make progress in various things. So you need to develop a capability to earn at least some part of the finances so that you can support some activity. And I'm very happy to see that in terms of the sponsored projects, NIOT has done a very good job in the sense that they are earning money, and also there's a lot of potential now, whether you are talking of agreement with Gujarat government or other things in terms of the various services. So it's a very complex mix of the activity which you have done, and it's a I would say that I'm very satisfied to see the progress that NIOT has made, particularly under the directorship of Dr. Atmanand. I'm sure the NIOT as an organization has matured and it has become kind of a independent of the person, but so far because there's a strong foundation now, and I'm sure that in future this kind of a commitment, this kind of a progress will continue to come. I would just say that very busy. I wish a very busy and tough and difficult life for Atmanand, even after post, you can say, retirement from NIOT, because he will continue to play a lot more role in the national context. All the best to you. Thank you very much. Go ahead, Nidhi.
Thank you. Thank you, sir. I request Dr. Shailesh Nayak, former Secretary MOES and Director NIAS, to please speak a few words, sir.
Thank you very much, Dr. Atmanan, Dr. Goel, my colleagues, Dr. Vladimir, Justine, and many others. It's very nice to see old friends on this. So I like that this occasion is extremely useful. If you really see the ocean, and Vladimir explained that why it is so critical, and I'm not going to go into the detail, but the one important thing which many of this, which Atmanand has been doing, the most important thing that the observations of the ocean, I think his contribution to bring the operational ocean observations for many applications, for the cyclones or for weather, I think it was remarkable. And we had a lot of buoys and all, but many of them were not working and there were many issues. And I think he managed along with Venkatesh extremely well. And today we have seen that many of during cyclones, our forecast used to be better than many other international agencies. The only reason was that our moved buoys were worked very well. And many times they were right on the path of the cyclones, but all the buoys all the time provided data in real time. So this was one, I think, is extremely used, the societal benefit which is done, and it is continuing. I think the whole team and has been geared up so well that it will continue for future. There are many new technologies Dr. Goel mentioned, and I think the drifting buoy technology, I think this is the first time in the world where we are able to get information every 15 minutes from the buoys. All other buoys gets data once in 6 hours. And the kind of trajectories which is now possible to get the information every 15 minutes is really remarkable. And I think this needs to be further developed. And since Vladimir is there, I would request that this could be taken up, for any other developing countries. It's much cheaper and much better than the many other things. There are many other things, but I won't go into the details of that. The second, which is a very critical thing, is to look at some of the resources and the sustainable development of those. And I think the technology which Dr. Goel talked about it, to build a lot of technologies to remotely operable vehicles, the coring machines, the drilling machines, and a host of it, the mining is needed something which was quite difficult. They have to work in extreme pressure and temperature conditions. And we have been one of the few countries who has this kind of a technology. So I think his leadership in this area has been extremely critical and crucial to lead the extremely dedicated team of engineers and scientists in NIOT to come to this level. At the same time, also, he has kept the newer technology to be continuously built up. And one major thing is in the ocean, the main communication is through acoustics. The amount of energy and the efforts and some of his extremely good colleagues which built the technology on acoustics is also extremely good. There are many things which is now operational. I won't go into details, but this is another area which I think is extremely important. As far as the resource is concerned, the first time with our own ROVs, we could get the information about the manganese polymetallic nodules in the Central Indian Ocean. And not only that, some of the very unusual, nobody believed that there would be the macrofauna on that floor. And some of the images which has been captured about the macrofauna is amazing. We just can't imagine. I don't know whether it has been identified or not, but that was the first time when we realized that at the 6,000 meter below, there are macrofauna. So preserving that environment is equally important for us. While we want to mine, but there is also life is there, and we need to protect that environment. So some of the studies have been done about the environment, what is the environment below, and a lot of work has been done by the team led by Atmanand in these aspects. The other two important things, very important projects. One is the tidal power station, which was to be constructed in the Gulf of Khambat. And this work, I know because since 1990, there are many international firms and all were engaged to get a primary data on this Gulf of Khambat. And the currents are very strong. It can go up to 8 to 10 knots. And practically no information was existing for that region for a very, very long time. Dr. Atmanand took up this challenge. And I must say, the first time, the continuous data, he set up 24 monitoring station in the Gulf, and continuous data was made available, a variety of things about the atmosphere, currents, and many other things. And this became a main basis, and which actually led to quite changes in the original idea of making the tidal power station. This was one of the very important contribution to the government of Gujarat, and I think this is the only work which nobody else could do. So this was really, really very praiseworthy. The second very innovative idea, which is the coastal erosion is everywhere, and many times we construct the breakwaters and groins, and the aesthetic is gone. And there was a beautiful beach in the Puducherry, and there was the erosion, very strong erosion. Myself and Atmanand both went together, and we thought we must do something. And today, there was a very innovative idea with Dr. Raman Murthy and all, that is underwater artificial reef has been constructed. It is mimicking the coral reef, and the beautiful beach has come up, and you can't see anything. That entire reef is now not seen, only you see a reef. And it is such a beautiful, and it is people there were so much connected with the beach, and they feel so happy today. Whenever I go to Puducherry, people are so happy to see that the beach has come back. So I can list many other things such which he has done, and he has been extremely creative. He looks very calm and quiet, but he is extremely committed, and at times, he can be very tough as well, and he has shown that what leadership means. And the NIOT today is one of the best institute in the country, and recognized outside as well, because I see a lot of people are spending time, Vladimir and many others. That means that what work Atmanand has done and NIOT has done is really important, not for India alone, but for the Indian Ocean and for the global community as a whole. So I wish him extremely well, and I'm sure that he would continue to be involved. There is a lot of work to be done. Vladimir said that the decade of ocean, so next 10 years, we are all going to be very busy, whichever way we can contribute. I think we all should work for the sustaining the ocean and the sustainable use of the ocean resources for the benefit of the mankind. The stewardship of the ocean only thing which is going to save us from all future requirements which we will have. So with this, I again wish Atmanand very best and extremely grateful to organizer to give me some time to talk to you. And the most important, I could meet my friends, though it was virtually. Thank you very much.
Thank you so much, sir. I now request Dr. Shenoy to please speak a few words. Dr. SSC Shenoy, are you able to connect, sir? I'm sorry, we lost connection with Dr. Shenoy. We'll get him back again. I request Dr. P.S. Nair to speak a few words, please.
Yeah, a very good evening, and let me first thank NIOT for giving this occasion to meet all old friends. Apart from Atmanand, I see several colleagues, and it is indeed a very pleasant occasion to be seeing and talking, though it is virtual. I would like to say only very few words. My association with Dr. Atmanand and NIOT is more than a decade old, and it has been extremely, I would say, very satisfying interaction which I had. And I would like to first say that Dr. Atmanand is one of the very few people whom I have seen in my professional career who is very calm, quiet, and with a smile, even under very provocative circumstances. And I don't know how he manages. This has been a puzzle for me and a surprise, pleasant surprise for me all these years. That is one thing which I wanted to say. Second thing is that his activities has really empowered NIOT to do and deliver many technological systems. I think many people have covered many of those areas. I will not like to go into that. But it is indeed very surprising to know that he is more than 60 and then he is superannuating now. It is in fact a bit difficult to recognize and realize that time is running so fast. I'm very sure that he will now get more active and more focused in delivering and helping to deliver the national goals in ocean technology in the coming years. Now that he is untied from the burden of formalities of directorship and associated work. And I also wish him a very active and very satisfying, happy post 60 years life, and I also use this occasion to welcome him to the Seniors Club. So thank you once again. Thank you, Atman. So nice meeting you online. So that's what I wanted to say.
Thank you so much, Dr. Nair. We have Dr. Shenoy back in the workshop. So I request Dr. Shenoy to please speak a few words.
Dr. Atmanand, Dr. P.S. Goyal, Shailesh Naik, Dr. Nair, other dignitaries, Dr. and other dignitaries and senior colleagues and all colleagues from NIOT. A very good afternoon to all of you. I am thankful to the organizers led by Dr. Ramdas for giving me an opportunity to join this workshop and participate in this valedictory function. It is very nostalgic time for me because I was so associated with NIOT for about 2.5 years, and I worked with the wonderful colleagues at NIOT and realized more about NIOT's potential as well as the importance of NIOT in the national life. It was very satisfying time for me, though it was a little tiring, but it was very satisfying time for me to work with NIOT during those 2.5 years. As previous speakers have mentioned, NIOT has developed several technologies. Some of them were not attempted not only in India, even in many other countries. Only few countries we can just count on one fingers of one hand. That's all the countries which are involving with those kind of technologies, and it is very honor for us that NIOT has taken up those challenges and um, did fairly good in developing several technologies. It was very nice to work with Dr. Atmanand even before I joined NIOT or came to NIOT. When I was at Incois, I used to interact with Dr. Atmanand for various projects and various purposes, especially on the ocean observation project, which is being handled by both the institutions. Similarly, tsunami early warning services, where the tsunami buoys have been handled by both institutions, and also on several other projects and works. It was a pleasure to interact with Dr. Atmanand and work on those kind of projects. I am so certain that Atma has contributed uh, um, considerably on the technology development projects, especially on deep sea mining, deep sea ROV development, in situ soil tester, autonomous corer, and as Dr. Shailesh Naik has mentioned, without his leadership and without his support to Venkat, the ocean observation system wouldn't have come back to life and start providing continuous data set. I thank Atma for all his dedicated work, and also I had opportunity to work with Atma on the international forums, especially at the IOC. We worked like a team, and we could make a difference at IOC because of the kind of teamwork which we could both, as well as Dr. Somsundar, who used to be with us at the IOC meetings. And Atma had taken up that challenge to resurrect IOC India, which was quite inactive for a long time. But after we agreed to revive IOC India, Atma has taken that as a personal challenge, and really he has revived IOC India, and now Atma is putting all his efforts to upgrade IOC India as a committee to a subsidiary sub-commission for the Indian Ocean region. I hope he will succeed in his efforts. Other fronts which we worked together were planning and promotion of IUE 2. Atma supported well in that international project, and also his contributions on implementation plan for the decade of ocean sciences. And on personal front, I must say that Atma is a very different person. Though we all tell that we should not get angry, or we should not hate anybody, even if somebody disturbs you. But I have seen Atma practice those kind of qualities in his real life. I know very well that the kind of trouble he has to undergo for some time, but he was very calm, he was very balanced, and he never even uttered a word of hate to somebody who is troubling him. That's the personal quality of Atma, and he's a good friend of mine personally, and I am sure that he's a good friend and philosopher for all of us, especially NIOT. And on this occasion, let me first thank Atma for his leadership and the technological contributions he has given to NIOT for the growth of NIOT. And I am sure that Atma will continue to be associated with the technological development in the country, especially the deep ocean technologies. And I wish Atmanand, because I always used to call him Atma, Atmanand and his family, a very healthy, peaceful, and very productive retired life. The retirement for Atma must be is coming out of the administrative responsibilities of director at NIOT, but I am sure as an engineer, as a technocrat, he will continue to work, and I'm certain that he is going to be very busy in those activities. With these words, let me once again thank the organizers for giving me this opportunity, and my all the best wishes for Atmanand for his so-called retired life, but very active life. Thank you very much.
Yes. Thank you so much, sir. I now request Dr. MP Wagdigar to please speak a few words.
Yeah. Thank you very much. Am I audible?
Yes, sir.
Okay, thank you. Good evening, everybody. It has been the unique opportunity for me to participate in this very important event. Thanks to Dr. Atmanand, Dr. Ramdas and his team. Today's presentation have been really enlightening, which covered broad-ranging, interesting topics with several experts from India and abroad participating in it. And in fact, this is the true tribute to Dr. Atmanand, who has been dealing with several multidisciplinary and multifarious activities over past several years as a director of this institute and contributed immensely to the growth of NIOT. I remember at this instance, Hemingway, I think you might have heard, he was the author of Old Man and the Sea, and in which the central character, the boatman, goes into the sea with varying thoughts during the rough sea conditions, and he finally manages to catch a big fish. Dr. Atmanand, and I have been the witness, also went through series of highs and lows, and on personal as well as on an institutional front. But however, he sailed NIOT successfully with several outstanding achievements in various fields. I think today's presentations and various talks have covered all of them. And even during this COVID times, I think the performance of the institute was perhaps at the pinnacle. I have been witness to his journey with several honors, awards, and various important hats, national as well as international. Perhaps I feel the key to his success is the personality, which is really extraordinary, uh, and the ability to remain calm under pressure on multiple fronts and remain committed to this work with a very positive outlook. On behalf of the ministry, we wish Dr. Atmanand a very fruitful and even more successful second inning on personal as well as professional front, with the very good health, happiness, and contentment. With all the very best, thank you very much.
Thank you, sir. And also on this occasion, I would like to mention that Dr. Sergey Sukonkin from EDBOE Russia actually just called us and wished all the best wishes for Dr. Atmanand. In fact, we've had many more people who wanted to join this workshop, but because of lack of time, we could not have them. So all the best, Dr. Atmanand, sir. And I request Dr. R. Venkateshan, Scientist 3 NIOT, to summarize the workshop. And sir, he started. He started. Sir, I think Dr. Atmanand want to say something before you start, Dr. Venkateshan, sir.
Thank you, Nidhi. Actually, this is a maybe out of the agenda because I had spoken first in the beginning, and when I heard all these things, I thought that it will be not fair on my part if I don't thank all of the galaxy of luminaries who have spoken so much about myself. And I don't know whether really I deserve all these, whatever has been spoken from this morning till now. But I really, in my own humble way, I accept it with all humility. And let me also just indicate that I was really fortunate to, become an engineer and work in basically as an electrical engineer. And then when I took up this operation of NIOT first in deep sea mining, as Professor Ravindran explained today morning, one thing is that I understood that we have to be very broad in NIOT. I mean, depth is one thing in our own subject, but the breadth is very much important because you should understand civil engineering, mechanical engineering, even to a certain extent metallurgy. All these things are required. Because of course, maybe I used to read and understand the subject and interact with all the people, and that made me possible to take this step. So the point which I want to highlight during the whole sojourn is that when I joined NIOT, I never had any, I never worked for anything. I just kept on working. That's all. I mean, all whatever happened, it just happened like that. So when I worked and it came up to the notice of the supervisor seniors, I remember even now, today morning, Professor Jagdish Kumar was telling that I had the occasion to move to IIT as a faculty. And I can just indicate that it was Dr. Goyal who told at that point in time, no, you should not go. He was the secretary and I was in the deep sea mining. No, you should continue in NIOT, whatever it is. This is what you should do. Then I agreed and I told him that I am not coming and I continued here. And later on when Dr. Shailesh Naik became the secretary, I had occasion to interact with him. He used to put me in some committees, etc. And then I think perhaps he understood that some stuff is there or whatever he understood, and because of which I had the good occasion to become the director of this institute. And after becoming the director, I should say that I had excellent support from all my colleagues. That is what I want to highlight at this point in time. None of the things which have been explained here are because of me. It has been because of the work of all the people from top to bottom, even the technician who has worked with his or her own hands, and up to the group head level, all have supported. There has been a lot of issues, as Dr. Nair was telling, there has been real technical issues which were really into, which we can really get off our mind. In the ship also, it used to be there. Sometimes from the ship, I remember Dr. Ramdas, when he is in the ship, some SOS will come and there will be some decision to be given in that split moment, in the middle of the night also sometimes. So many of these things our team has really helped in bringing up all these to a complete success. Similarly, administratively, I had a lot of challenges. Of course, many things are still not over. Many issues are still there. One of the issues was when the ship got into trouble and we had to cancel a cruise, Southern Ocean cruise. We had good support at the time from Dr. Shailesh Naik as secretary. And after that, of course, there has been some tribulations which I just forgotten. Let me not worry about it. I only been made, you know that when the steel is annealed, it gets more and more strong. So it only made me more strong in my mental and attitude towards the work and other things. So that has been a good uh, so to say, experience for me, even though it was not a good experience, but it made me more strong. And towards the end, the last 2.5 years, we had Dr. Rajivan, and he has been also fully supportive of all our activities. And not only our NIOT team, but the MOES team has been really supporting me, I should say, starting from Dr. Das, Dr. Vaktikar, Dr. Vijay, Thakur, everybody, Prashant, earlier Soma, KJ Ramesh, all of them had, I don't want to, if I speak some names, maybe if I leave out some name, it may be, some people may get offended, so I don't want to really tell all the names. So there has been a good support from everybody, and that is why it was possible that NIOT has come up to this stage. And I'm sure that one aspect which Dr. Shailesh Naik told me when I took over as director is that, see, the thing is that in the institute, there should be a system. You should bring a system in place. That is most important. Once the system is brought in place, then whether X, Y, or Z is the director, things will go smoothly. So I think that I have worked up to his expectation, and I feel that there is a system of management council and discussion with seniors, and decisions are taken based on that. All these things have been put in place, and I should really say that even during this COVID time, all of my teammates have supported me. And one point also I would like to highlight, that perhaps I really do not know I have succeeded in getting over anger. I really get angry in some occasions. Maybe rare I got angry also. Maybe perhaps I do some spiritual practices in the morning, and maybe meditation and pranayama and all. Maybe that is the reason because of which it is so. But still, I don't consider myself as perfect, even in a 0.1%. I think you have to really work on. So my role models were Dr. Goyal, Dr. Shailesh Naik, and many others. And I'm also happy that during the period of time when I had a lot of tribulations, I had full support from Dr. Shanai and Dr. Rajivan, because that was a time when, things were not going on well, even though all efforts were being taken, but both of them supported me. And more than that, all my team members, they never showed any difference in their attitude towards me. That was really great. And I'm also happy that I am now in a very happy and contented manner. I am retiring, and I'll be really happy to contribute in any way, but not in a permanent way, coming here and sitting. That I will not do. But in any other form, in committees or meetings or anything, I will be very happy to contribute. And even the IOC India, we have got a lot of work to be done. I think that first onwards, I will be again disturbing Mr. Justin for some reports, and maybe Dr. Vladimir, and we have to hold a teleconference and all those things has to be done. So I would like to once again thank one and all, and I would really like to thank Dr. Ramdas for organizing this event. It has gone in a very, very meticulous way, because he knows my way of working, especially in organizing events. So it has gone in clockwork precision without any delay. I was really worried that things will get delayed, and especially when we have foreign speakers, delay is not at all appropriate. But I am very happy that it went very well, and all the organizers who really did a meticulous job. I once again thank everybody. If I left any name, I'm sorry, it was not intentional. Thank you very much, and wish you all the best, and NIOT also all the best. Thank you.
Thank you so much, sir. I request Dr. Venkateshan to please summarize the workshop. He's not audible. Sir, you're not audible, sir. Dr. Venkateshan, can you hear us? You're not audible, sir.
Yeah, how is it now? Am I audible now?
Yes, but
am I audible now in this, or we can come out of that? You come.
You are audible, but you are a ship engine room.
Oh, there's maybe AC. Let's check in. Okay, it's expanded. Since I click it. Here. Is it audible now? Is it audible?
Sir, it's audible, but there's a lot of noise.
Yeah, I will continue now. I'm coming closer. Sorry, there is I had a blink before my switch on the volume. So am I audible now? Am I audible?
Okay, go ahead.
Yes, sir. Respected Dr. Atmanat, former secretaries and former directors and colleagues from MOS and my colleagues. It gives me immense pleasure. Before I start the summary, I would like to share my experience with Dr. Atmanand. He brought me when I was on deputation to Sri Lanka. I was working in UNAP Regency's program, and he gave this opportunity to work in the National Data Program, which, like Dr. Shailesh Nayak said, it was really a challenging task for us to restart this program, and today it is found credit goes to him. So I will not take much of your time. So in my summary, I would like to say that there are about 213 attendees, and we had about 6 multidisciplinary sessions. We had about 8 international and almost 8 eminent scientists were present. One of the important aspects was ISO award was presented to him. I would also like to congratulate Dr. Vladimir. Last week he was given an MTS Compass Award for his contribution. So I have compiled this complete report. We have eminent speakers like Dr. Nandagopan, who has spoken about NSTL and interaction with NSTL with NIOT. And in the preliminary session, Dr. Goyal had briefed about his interaction with him, followed by and our secretary had spoken about how Dr. Atmanand has brought this institute to the international recognition. Then followed by Dr. Ravindran, founder director of NIOT. He mentioned about his interaction and from the beginning how he has coordinated with him. Then my colleague Dr. Purnima Jalihal, she had compiled about what are the activities we have planned on the whole day, and that has been executed in a meticulous manner. And finally, Dr. Ramdas, who had given a vote of thanks. We are very happy that Dr. Vladimir is present here in spite of his busy schedule. We thank him along with Mr. Justin. So this is the best way one can inaugurate the program. Followed by Dr. Jagdish Kumar also mentioned about is how, as a scholar, he had worked along with him. What is his experience, particularly on the electrical aspect? That he explained it very well. Then the first session was chaired by Dr. Dilsha Rajappan, who really initiated the discussion with inviting these eminent speakers to speak about that. And Dr. Sanil Kumar Singh, Director NIO, he spoke about GeoTraces program, how the science was developed by interaction, how NIOT also contributed by providing the ship time. Followed by Dr. Tiwari, his experience on subtectonic, particularly Sumatra, and where the subduction zone process, everything is presented in a more elusive way, where as a technologist we could understand when you talk about tsunami early warning. Second session was chaired by Dr. Gopakumar. He had Dr. Ravichandran from NCPR. In fact, he mentioned about his career in NIOT, how he started the NDPP program, how he is coordinated with Dr. Atmanand for Arctic program. And in this presentation, he showed about the importance of Southern Indian Ocean, how this ocean through flow, and particularly ITF really plays a major role, and what is the importance we need to understand about this Southern Ocean with the upper ocean heat content. He also suggested that like omni-mooring, what you got a network, there is a need to have in Southern Ocean also. Followed by lecture by Dr. Ramanamurthy. He has mentioned his interaction with Dr. Atmanand, in particular in the challenging time, how he has developed this desalination plant and how that has been working satisfactorily. How at site there was a site decision need to be taken. He had close interaction with him. He also spoke about techniques adopted on the coastal production, where the success story NIOT could reach to the society on a beach restoration, particularly on Pondicherry, was well explained by him. Finally, in this session, Dr. Srinivasa Kumar, he spoke about his interaction again with Dr. Atmanand. He spoke his experience with IOC in the region, particularly how the Tsunami Early Warning Center was evolved, how India could attain this position of recognized early warning center, how the tsunami is in its own water, and the technological need is required now. Presently, there is a challenging time like what happened in Indonesia. There is a need to look for a newer technological solution. He spoke about it, and particularly the cable observatory, where NIOT can play a major role. The third session was chaired by Dr. Lata. She mentioned about her interaction, how the ocean acoustics were developed under the leadership of Dr. Atmanand. And also by Dr. Murali, he spoke about the wave-breaking induced activities by one of his students, how these studies could be really helpful, particularly for the characteristic debris, how the coastal protection can be done on a theoretical study. Then Professor Chung, he could not be present, but he has really mentioned about his contribution of Dr. Atmanand, and then he was awarded this ISOP award. Then the fourth session was chaired by Dr. Tata Sudhakar. Dr. Kawaguchi, really he spoke about how the JAMSTEC is doing in Japan on unmanned marine vehicle and the AUV, and how in the Asian country he could work together for an X-Prize program. That is really challenging. We could take a lead in future. We can interact with industry to also develop such an X-Prize activity in our country. Then Professor Rain, he spoke about ocean best practice. Recently, he shared a session on particularly how remote monitoring of marine pollution, particularly on oil as well as on plastics, how that could be done, how the oil spillage could be done. There is a lead for us engineers like us. We could take a lead and work on a remote sensing activity. Then Professor Manil, he had a very close interaction. He has been visiting our institute. His nostalgic moments he shared. In particular, he spoke about synthetic aperture sonar, ACS, how it is an importance, particularly for seabed mining, how with the practical application for naval and civilian application, how that could be useful. Then the fifth session was chaired by Dr. Jana, and he also mentioned about his work in coastal engineering. And Dr. Gopakutti, he presented how difficult it is to go for an observation, how difficult it is, particularly for acoustics, what are the different need and different challenging times are there. He also mentioned there is a need to bring a passion for the youngsters to work in this field. And a very interesting talk was by Dr. Hanu, my good friend. He spoke about his present position in the Northeastern University, earlier experience, how he had developed, particularly on image processing technique. Very interesting tools he has shown to us. Even though we are working on it, there's a lot way to go from his experience, and particularly on machine learning applications, he has spoken about it. Then these two lectures were compiled by Dr. Jana, followed by Dr. Ramesh. The last session, Dr. Venugopal, he really shared his experience interaction with Dr. Atman and the IEEE, and on a backscattering aspect on polymetallic nodules, his work he presented very well. Finally, very interesting lecture by Dr. Vladimir. He spoke about IOC, the importance of the ocean UN decade, how the technological need of Dr. Atmanand has contributed to the UN decade preparatory plan, how in 97 days we are ready to start with the UN decade of that. Validatory function, it was well attended by the well-wishers of Dr. Atmanand. Dr. Shailesh Naik, he spoke how he has supported and revived this ocean observation, which was a part of it and a good experience. And he also spoke about drifting buoy technology and many other technology development which this institute has done in the last 1 decade, how that need to be continued. Dr. P.S. Goyal, he spoke about pursuit of technology, in particular on man-submersible, blue economy, and recent times the growth of NIOT has got a larger role to play, where the contribution by Dr. Atman was well appreciated. Then Dr. Shanai, he had a very close interaction with him as a director of INCOIS, as a director of NIOT, and his how helped us to execute the duty and how he would lead these activities of NIOT, that was well presented by him. Also, his experience in the United Nations UNESCO activities was also presented. Then Dr. P.S. Nair, he mentioned about how significant achievements have taken place last few years by the contribution of Dr. Atmanan. Finally, Dr. Vaktikar, from his experience from the program division angle, how he has coordinated and executed, how this institute got benefited by the contribution of Dr. Atmanan was well presented. There are few points I could compare from this that was required in the initial inaugural session itself. It was told. I just compared the way forward where we can go, like NIOT and NPL can work together. Long-term observation, Southern Ocean is required. Particularly the EA moorings, what we are planning could be expanded. Tsunami early warning applications could be taken. That is a potential. Then IIT work on wave modeling could be worked along with our coastal protection activity. And finally, an expertise on unmanned, particularly marine observation related technology, X-Prize, remote monitoring of marine pollution, as well as the synthetic aperture sonar, capacity building. That was really spoken about it, how NIOT can play a major role within India, in the region as a whole. And development of underwater imaging is a long way to go, but these opportunities are really brought out very nicely in this lecture. Finally, Dr. Vladimir start how and Justin also spoke about how we can support the neighboring countries where there is a need for such technology development to be done in the interest of ocean decade as a whole. With this, I conclude. Thank you very much for the opportunity given.
So much, sir, for summarizing the workshop well. On behalf of the organizing committee, I would like to thank all the speakers and participants for making this workshop a big success. Thank you, everyone.
Thank you. Thank you all once again. Thank you.
Thank you very much.
Okay, thank you.
Bye-bye.
Bye-bye. Atmanan.
Thank you.
Yeah.
Thank you. Bye.
Thank you. Thank you very much. Bye.
Bye. Thank you.
Thank you.
Thank you, sir. Thank you. Thank you, Vladimir.
Take care. We will be in touch soon for the
Yes,
senior.
we will be. I'll be more active after first.
No retirement, no superannuation. Come on. See you soon.
Okay, see you. See you, Justin. See you. Thank you. Thank you all.
Thank you, sir.
Thank you.